Yep, yeah.
There we are.
Here we are, yes.
Good. Now let's see. Find a timer somewhere.
It's in the settings up there somewhere. There's a clock, the orange, yet again orange.
Ah, counter clock. Ah, okay.
Yes.
Didn't look there. So I don't need anything else. Cool. So I can say something like, "Give me 5 seconds," and do a
They're
countdown.
going.
So only I see that countdown, or anybody else see that as well?
We see it as well. Stop, it says. Now it's 5 seconds. Four, three,
Okay.
two, one.
And
Bang.
how do I move it out of the way so I can actually see things?
You can't. It's there.
That's annoying. I want to see the presentation as well.
You can. You can. It will be in the middle. You know, in the where you can now see stretch with Lenka and things like that. There's where the presentation will be. You will still see it all the time.
Okay. Well, nothing else is
Unless you
there.
have some full screen option. We cannot hear you, Jan.
Okay,
No, we cannot hear you.
there's the schedule.
We're live on air. We have to be careful what we say.
It's all your fault. Just to be
No,
there you are, Jen.
I'm trying to remember how to upload slides.
Okay, I have
It's horrible.
countdown. So well,
Tim is eager. He has already asked for permissions, but we're first going to do some other stuff, I guess.
let's say.
Okay. So, share preloaded slides.
Today. So it's 8, 6. Ah, crap. Sorry.
You're live.
I know. I don't care. I don't care too much about political correctness. I mean, I do care about. No, political correctness is just mannerisms. I find it much more important to actually I think it's much more important to actually have some respect for people, and that doesn't have that much to do with manners. I mean, you can be very polite and still treat people like you're an utter moron, or you think they are an utter moron, whatever. And there we go. So I have a bit of a timer thing, but this is annoying. Actually,
3 minutes.
Yeah, I'm back in a second. I got that thing. Oh, I need some more tea. Get that as well before we start. So there we go. So did I do that? Did I do that with the countdown clock, or is it somebody else doing that?
You.
Okay, it's good at that then.
Yes. Got there.
Beautiful color, isn't it, Ray?
Yes, yes, especially for Dutch people. Yes. A royal color.
I will behave myself
Somebody
and
would
not show.
complain. Somebody would
I will
complain
not
about
show
any
my
color I
middle
choose.
finger. I will not show my middle finger.
But probably
You
the
know
most.
that it's a.
The
This
problem-
session is being recorded. I'd like
I
to
know.
remind everyone. Okay,
Sure.
good.
I'd say the best color to use here to offend the least people is to go for black on black.
No, I think the white on white, so it will be every color, right?
Yeah,
So nobody would complain.
people here care
All
more
right.
about black than white. I've seen more people in black t-shirts than in white t-shirts at the RIPE meeting. So, oh my.
It's because we keep all the heat in, we consume less energy.
Yeah. Anyway, let me get this thing up and running.
1 minute.
Yeah.
Can you hear me all right, by the way? I'm getting complaints that my microphone is not good. Okay.
It's a bit metalish, but it's because you're on the other side of the planet. Don't worry. We can hear you loud and clear.
Sorry, I would love to be close to you guys, but I'm living on an island, which is closed currently. Nobody getting in or out, so.
No.
I thought it was a continent.
It is an island.
That's a
It's just
tricky question.
huge. It's a
Okay,
huge
anyway.
island.
Shall we actually start, because it's exactly 6:30 p.m. for me, and we have a packed agenda.
Go for it.
And yes. So, welcome everyone to IPv6 working group, another virtual one. We have a packed agenda. I can ask if anyone has any suggestion to agenda bashing, but I suspect we don't have time for anything, but you can suggest privately to the chairs if you have any corrections to the agenda, and we can consider it during the session. We'll do our best to accommodate your suggestions. And etiquette. Yes, when you go to the microphone, please state your name and affiliation if you have one. I hope everyone now familiar with how to use Meet Echo. If you don't, there is a button for you to send the video and send the audio. So please join video audio queue if you'd like to ask questions. You can also ask questions in Q&A section, and we will read it out loud. Housekeeping. I probably should do the poll, right? How many people read the meeting minutes from the last one? I actually have. I don't have any comments. I would say, please take a look if you said anything during the last meeting and check if those meeting minutes are correct. I believe Ray sent them to the list. And before the end of this session, please let the chairs know if you disagree with the current versions of the meeting minutes. Otherwise, we'll consider them approved. Okay. And rate the talks indeed. And, oh, you see, I've done it in 2 minutes. So now I'm passing the microphone to Ray, who is going to talk about the chair reselection.
Yes. Good morning, everyone. And Jen has been doing a great job for the last 3 years. And Jen was planning to step down, but we don't let her really. So after a small conversation, we had acknowledgement that she is willing to continue if anyone else doesn't want her job. We put that stuff on the mailing list, and guess what? No one dared to step up, say, I want her job. So with that, we confirm hereby that Jen is again for the next couple of years with us. Thank you.
Cool. Thank you. So, share preloaded slides. Shall I do this? Share, and I guess I need to upgrade.
Jeff is already upgraded.
Already.
Yes. He
Perfect.
just needs to open his mic. Jeff, we cannot hear you. Please open
the
your
mic is open. I have exactly 10 minutes, so I'll be as quick as I can. This is a presentation on an update on IPv6 fragmentation. Now, I don't seem to have control of the slides, Jen, so you're going to have to do advance, please. No, I didn't say to. Yes, thank you. Okay, so this started with an RFC 7872 published in 2016, and it actually referred to work done in the previous 2 years. They sent fragmented V6 packets towards the well-known V6 servers using the Alexa Top Million and the World IPv6 launch set, and found the following drop rate there underneath that blue arrow. And for web servers, they were seeing upwards of around a 30% drop rate at the most optimistic level, with some numbers getting worse than that. That was certainly a shake-up. It's kind of, doesn't fragmentation work? Next slide, please. So at APNIC, we decided to actually replicate this experiment, but actually use the opposite data flow from the server towards the end client. So again, what we're doing is using our measurement platform that uses ad-based measurement. And across, at the time, August 2017, across 1.6 million V6 clients, we sent them fragmented V6 packets. And in this case, we actually tried to understand if they got them. And the way we did that was we looked for the ACK. So we send the frags, we're listening at the server, did you get them? If the ACK comes through on the TCP session, yay, you got it. Fragmentation loss rate, 21%. Getting better. Next slide. Now, at 21%, that's still pretty shocking. In fact, worse than pretty shocking. Thumbs down, can't fragment. I'm like, horrible. And so we thought this year we might rework that experiment and actually look at this again, using exactly the same kind of methodology with one subtle variation. So it's the server to client. We're fragmenting large packets as they head towards the client inside a TCP session. It's an HTTPS web session, it's what everyone does. And we actually constructed a middle box that did this fragmentation, which is actually a subtle variation of IPv6 NAT and incredibly precise control on the way fragmentation is actually going to happen, because we're doing the fragmentation almost by hand code. And we detect the drop by actually looking and listening for the ACKs that come back, because the other end, if they're receiving all the fragments, will reassemble the packet, send it to its TCP engine, and sooner or later we'll get an ACK of those session numbers. If we get the ACK, you reassemble the packet. If the session hangs, thumbs down. But this is the twist. This time we were actually mucking around with what's the fragmentation size that works best, and when you vary that size, does it alter the loss behavior? And we've been doing this now every day for the last 3 months. Next slide. And it's kind of interesting. We started in early February with a 10% loss rate, which is much better than 20%. And then very quickly it swung down. And for the last few months, it's been hovering around 6 to 7%, moving up to 8 at points. This is amazing. There are 10 times the number of V6 users since 2017, 30 million to 300 million. Yet the fragmentation rate appears on average to have dropped by 2/3. So are we getting better at V6 fragmentation? Yes, you know, it's actually working a whole lot better. That's still not the best number, but it's certainly not the worst. Next. The problem with any kind of 1 point measurement is that there's a world of detail behind it. Red is a 10% drop rate or worse. Anything less than that goes yellow and then goes green. And this is, by and large, an odd map. Where we have a lot of V6 that's been around forever, the US is certainly one of those cases, deployments in Europe, the loss rate's above 10%. And it's actually only in India, Iran, bits of Russia, Myanmar, and over there in Panama, and I think that's, no, I won't guess, you can figure it out, just below Guatemala. Really, really good. So what we're actually finding here is a conclusion that the more recent V6 deployments are doing a whole lot better than the older ones. Maybe the older ones are being masked by happy eyeballs or some other thing, but you know, loss rates vary a lot. Next. Moving as quickly as I can here. Next slide. Drop rate by size. Now this is the bizarre thing. You can see a very, very slight bump at 1280 where 7.4 average drop becomes 7.5. Yeah, don't know quite why, but it is very marginal. But what's this? I'm like, that's completely unexpected. Why is 1408 octets getting almost a 1.5% higher drop rate, closing to 2%, than the smaller ones? I'm like, if you're encapsulating 80 bytes of encapsulation, that's a lot of tunneling. And it's kind of, this doesn't seem to make a whole lot of sense. And so we dug a bit deeper. Next. And what we found was even more confusing. In North America, the drop rate's around 11% irrespective of size. European providers, well, subtly different, because up until around 1380 bytes or so, the drop rate is around 12.5%, and then it swings up a little bit higher to 13% for the larger packets. Don't know what you guys are doing over there in Europe, but that's just weird. That's bad, bizarre. Asia, almost a bit like Europe, but slightly more gentle. But you notice the absolute values, it's 4.5 up to around 6% there. So Asia, it's not quite as bad, but again, larger packets have dropped more frequently. No explanation on my side, don't know. Next. Of course, we actually have enough data now that we can look inside service providers. If you're curious, AS852 is TELUS in Canada, major provider there. The drop rate has got better. It swung down from 100% to 80%. Well done. Good. On the other side, one of the largest V6 deployments we've ever seen, which is Bharti Airtel in India, which has a client base in V6 population numbering in the hundreds of millions, drop rate 1%. It can be done, guys, in Canada. You know, tell us, it really can be done. You can make it work brilliantly. Next. Next slide. Why? Well, it could be local security policies. There's a whole bunch of networks that just don't like fragmented V6. Microsoft's servers, for example, just simply block it. And a number of other service providers simply go, well, just don't fragment, please. We're not going to accept it. More likely is actually that the extended header options in V6 trigger slow path processing. And once you go into the slow path, the drop rates get higher. Now, that's not 100% drop, but it is sort of a slightly higher than nominal drop rate because the slow path invariably actually has a higher drop rate. And it's hard to believe, but there might be some IPv6 path into UOs. But don't forget, our fragmentation policy is we send a packet a lot smaller than 1440 or 1500. We're sending an initial fragmentation packet down between 1200 and 1400 at most. So it's unlikely to be path MTU, but who knows? It's the internet. Next. There's a daily report. We produce this every single day. It's an ongoing measurement. There's a URL. If you screen snap in the next 2 seconds, that blotchy thing down at the bottom where the QR code will actually lead you to that page. Too late. Next. Summary. We're getting better. It's improving a lot. 5 years ago, thinking about fragmentation in V6 was in, you've got to be kidding. That's the worst idea you've ever had today. Don't fragment. These days, the answer is, well, you may have had better ideas today, but it's not completely insane. Fragmentation will work a fair deal of the time, unless you're in Canada and a customer of TELUS, won't going to work. But it'll work more likely if you're inside a country or a network that has had a relatively recent V6 deployment, and they're doing much better handling of V6 fragments. The more mature deployments, the news is still bad. For some reason, smaller frags are more robust than larger ones. So if you're going to fragment a packet, don't produce the largest packet you can in the initial fragment size and put the trailing small bits afterwards, which is what most hosts do. Don't do that. Slice and dice evenly. Keep the packets smaller, and you'll actually stand a better chance of getting the fragged packet through for reasons that, I don't know. Maybe someone can tell me why packets higher than 1280 have an accelerated loss probability until you get up over around 1400, where it's sharply higher in some networks under some circumstances. And I think that's it. Next slide. Yay. Questions? Or not?
Okay. No, I see a question in Q&A session. Okay. Lars Brian is asking, hi Jeff, from how many vantage points do you measure? Is it really the end host that fails, or might there just be a few misconfigured choke routers close to your vantage point through which the most traffic for the America-based devices passes? If so, could it be that your numbers might just reflect the fraction of devices routed via those choke routers?
We use 4 server points, and if you actually have a look at Canada and the US, you'll find that different networks have different loss rates. And so it's actually far more likely that this is close to the edge, not close to us. Also, from each of those 4 points, we measure basically entire continents, so that we're actually not finding that the choke points are close to us, Lars. It's way more likely that the choke points are actually closer to the user, and they're either very close to the user or in the network, that last hop access network. Next question, I'll go quickly because I know time's of an essence. Did my tests include atomic fragments? I don't know what you mean by atomic fragments. So the answer is meh.
Yeah, may I clarify? I think actually, yeah, I think so. Basically, it was so you said 2 fragments, right? Initial large one and smaller one. It was just one packet with fragment header, but no subsequent fragment.
Oh, null fragment header, that's coming up. Tune in about a month's time or so and we'll have some data. We're trying to actually understand whether, if you will, a null fragment header, just having an EH that doesn't mean anything, is going to do anything or not. So no, haven't measured that yet. Firewall set the MSS around 1380 is the next from Ivan Beveridge. Yes, but some seem to go at 1400. Some seem, you know, so that setting of when to drop a packet, how big does it need to be? If a firewall sets an MSS down that low, it's asking for, you know, trouble. It's just, do you hate your traffic that you're passing through? It's a bizarre kind of thing to do. It's very low. David, have I done tests with fragment sizes less than 1200? No, 1200 is the smallest we did. Oliver, what's the baseline drop rate for V6? Different talk, different time. I've run out of time. It's around 2% from memory. I haven't looked in the last couple of weeks, but that's a different report in the site we use. So at this point, I think the base rate is 2%. Example configurations for ISPs and enterprise to show how to make it work. Yeah, don't drop fragments. I'm sorry, it's as simple as that. Just don't drop them. It's more actually get your router vendor not to drop packets with extension headers. What can people inside the particular countries do to make this better? I don't know, Jan. I think equipment has changed. I think what was on the market 5 years ago is now different to what's on the market today. But, you know, I don't build networks and I don't buy this equipment. But I think the folk who are buying today actually are getting better equipment. And I don't know exactly what aspects of that have improved, but something sure as hell has got a whole lot better. Will I publish the data with PerAS? Yes, that's all on that URL I gave you, Alex. Just follow the link. Have I considered testing a drop rate of fragmented packets with other V6 options that trigger slow path? I was actually discussing this with Joao this morning. What other extension header options other than a null fragment actually make sense? No one uses Nimrod, so the Nimrod routing header doesn't work. Now, there's a whole bunch of extension headers in V6, but most of them are, to put it politely, crap. And so if you can find me extension headers that people want to use in anger on the network, I'll happily test them, but I haven't done so at the moment. And I think we've exhausted the Q&A, so I'm going to hand it back to you, and we're about as close to 10 minutes as we're ever going to get. So thank you all.
Thank you very much, Jeff, for such a positive presentation. I'm so excited, and thank you for doing measurements, which I always would like to do to see how we're improving over time. I think we'll continue the discussion offline, and I'm looking forward for more measurements from you, which proves that we can make that thing work.
Thanks a lot. Bye.
Thank you. Next, Tim.
Hi there.
So, all right. I'm going to be your human interface to moving slides.
Okie dokie. So, hello everyone. So I'm here as part of a group that's working on an update to RIPE 554. It's myself, Marika, Sander, Tim Winters, and Jan. Next slide, please. So this is the RIPE document on IPv6 ICT tender guidance. The previous version, the second version, is almost 10 years old. So we agreed at the last RIPE meeting when we presented this that we would get on with updating it. We've had some discussion amongst the group of authors, and we feel what we should really focus on is to update the content as it is without adding new categories, new sections to the document. We feel if we can publish a new 554 with everything moved forward with 10 years of new RFCs and operation experience, that's a very useful thing to do. And if at a later date we feel we should add, someone feels they should add extra categories or something else, then we can look at that then. So that's the sort of scope of what we're doing. We are keeping the linkage to the IPv6 Ready logo program in because that's still an active program. As part of that, we brought in Tim Winters as an extra author, as he has quite extensive experience with that and interop. If you want to look at the current draft of the update, there's a Google Doc there that everyone has view access to, so you can look at that. I also emailed a PDF of that to the list 2 or 3 days ago. And please, if you've got comments, send them to the V6 working group list so we can have discussion there. Next slide, please. So the sort of status of the work, we have actually, having said we wouldn't add extra categories, we've actually removed one. So there was a category of mobile devices in there, but we agreed that since that also led into 3GPP requirements and things that certainly the author team didn't have expertise in, we felt it would be much better, for the time being at least, if we remove the mobile device category and just consider mobile devices as hosts that might be connecting to local infrastructure. So really you're thinking of the Wi-Fi connectivity for mobile devices rather than the 4G, 5G, whatever. We have added reference to transition mechanisms, ones that sort of weren't really mentioned 10 years ago, like MAP-T, MAP-E, DS Lite, but the focus there is on the V6 only access networks. So it's very much V6 only access networks to legacy. So that's probably mainly included in the CPE category. So I remind again, the categories are hosts, switches, routers, security equipment, CPEs, and load balancers. Those are the 6 categories of equipment in this document at the moment. IPsec remains optional. We saw no reason to change that, but there was quite a large discussion about that last time. And most of the work to date, other than that, has been about updating reference to RFC. So, for example, 2460 has become 8200 for the IPv6 core spec. There's been obviously a lot of RFCs published in the last 10 years, so it's been about updating the ones that have been updated and adding new ones that we feel are relevant either to the mandatory or the optional sections. So in doing that, there's a lot of additions and updates, so it's quite possible that people in the audience will think, well, maybe they shouldn't have added that, the authors, or maybe they've missed my favorite RFC. So kind of the stage we're at the moment now, keeping the scope of the document as it was, is to get feedback on the list about which RFCs we've added, maybe shouldn't be, or ones that we've missed. So that's the main thing we'd like to hear from you. So as an example of that, RFC 8601 is now listed as mandatory. That's the RFC about including DNS server info in RAs, for example. So that's the sort of thing we need comments and feedback on. Next slide. So things we know are on the to-do list still. America has still to sync the security section with the quite massive now IETF OPSEC Working Group V6 security draft. That's something I ended up being a reviewer of over in the IETF Ops Directorate. That's a 50 to 70 page document with lots of guidance on applying V6 security practices to V6. It's quite a good document for people to be looking at. That's hopefully going to the ISG soon and therefore being published soon, but we should sync that with what we're saying here. That's the key point. And then once all the RFCs that we are going to include in the mandatory and optional sections in this update are agreed, Tim Winters will go through and check how that correlates against the IPv6 Ready logo program, which I think is an important thing to do. So then we can indicate in the document with asterisks, as is the case now, which of our mandatories and optionals are also listed in that program. We've also noticed we probably need to look at things like netconf, yang, restconf, where at the moment we're only mentioning SNMP, and there's a few other little minor things we need to consider, like whether the sort of things like Bonjour, MDNS, DNSSD should be in there as optionals. But basically what we really need are comments on the document as it is now, so please send those to the list. Next slide. So that's it. If you, you can email me directly, there's my email address, but we would much prefer it if you sent questions to the list. I've had one email sent to me about a specific RFC and whether it should be included. The interesting thing there was it was published in February or March this year. So I think since we first did a pass of all the new RFCs to see which we would include in here, there's probably been some published since then. So we probably need to repeat that exercise for the last 3 or 4 months just to be completely up to date. So that will be also on our to-do list. So, but yeah, please send things to the list. Right. Are there any questions? Thank you. Let me just see if I can see the.
Yeah, it looks like there are some questions in the question section. Tim, can you read them, or do you want me to read them?
Yes, I can see the one from Geordie. Obviously, I know Geordie's contributed a lot on this particular topic in the IETF. So I think 464XLAT will be in there. I'm not sure about lightweight 4/6. But yeah, please post to the list your comments on that. I think 464XLAT will be mentioned along with NAT64 and DNS64. But yes, thank you, Geordie. Your input would be very welcome. Are those questions in the chat, or are those? Should be a living document. Yeah. Yeah. Sorry,
chat
Jen.
should not be used for questions.
Okay, right. Sorry.
Yes,
I'll stop looking at chat.
Yeah.
I'll ignore chat.
If everyone, so if everyone has questions, please put them in the question section so we clearly know it's a question and not just a discussion in the chat. Okay.
Thanks, Jen. Yeah. I mean, if there are no further questions, we can move on. But yeah, comments to the list, please. What we'd like to do is to get all those comments in and the documents into a sort of a final draft by the end of May. Might be optimistic, but and then we can ask the chairs to consider how we would go forward from there once we think we have a final draft that no one's objecting to.
Okay, I think we have Jan who would like to say something. Let me.
Hello.
Right.
As the quarter, I would just like to emphasize what Tim said. This is just the update of the document, the current update. We would like to publish it as soon as possible because lots of people is using it. And then if we want to add sections, if we want to add things, we will be aiming for an update of this or something like this. But I would really like to see all the comments in as soon as possible, so we can just publish the update and get on with work with additional comments, additional sections.
Great, thanks. Yeah. All right, thanks, Jim.
Next presentation is Yanis. I guess you go into present, right, and share your screen.
Hello. Hi. Hopefully you can hear me. Can you hear me?
Yes, we do.
Good. Hello. Thanks for joining in. This was the original title of my presentation, but the new improved title is this one. So this is a presentation about the rocky road towards our IPv4 as a service, and this is the third chapter in this MAPI. So just to get you up to speed a little bit, we've been doing, as an ISP, we've been doing quite a lot of IPv6 in the previous 10-15 years. As far as this measurement goes, I think we're about 80% on the IPv6 deployment measurements. And as I said, we've been doing IPv6 for a few years now. We have a project running since 2009, and we have been providing services to our end users since 2013. All residential service users, business users, fixed line BGP, and in the past 2 or 3 years, I think we've been providing a dual stack service for our mobile users as well. Almost all of our residential users have native IPv6, and we have been convinced for a long time now that IPv6 only is the way forward. We did skip some of the transition mechanisms like DSLite or 6RD, not because they were not good, but because we were preparing for the next generation of mechanisms. If people want more information about our IPv6 deployment as a whole, you can check out this link. So this is a brief timeline for our IPv4 as a service journey, which started about 6 years ago. April and May 2015, when we did our first MAP-T and MAP-B trials respectively. The first ones we did were on a Cisco ASR 1K machine with, I think it was still the experimental MAP-T code, and with the only CP that was supporting MAP-ENT at the time, which was OpenWRT. Same thing with MAP-E, we just used a different Cisco, and we also used a service module at the time. Then came Lightweight 4/6. Again, there's a link if you want to find out more information about that deployment. It lasted about 2 years. We had to put it to rest for several well-documented problems. And around the beginning of 2020, we thought we'd give MAP-E another go. And here we are, almost a year later. So for people that might be starting out right now and thinking about transitioning to a technology such as MAP-E or MAP-T or even Lightweight 4/6, have to know what are you competing against. In our case, at first it was easy. We were competing against a single stack CGN, and it's easy because it was a temporary solution. I mean, honestly, we keep saying that to ourselves, even like 5-6 years later. But anyway, it is expensive to scale. That's true. I mean, those service modules cost a lot of money, and as I said before, we were convinced that you cannot have a future without IPv6. We take that as a given. We still do. But then we had an epiphany, and we converted our CGN to dual stack, and then it wasn't so easy to compete against that because, okay, we have to get rid of the expensive service modules, but what else? Honestly, we couldn't think of any more arguments that had any essence. So also keep in mind that, yeah, I mean, people like us might be doing dual stack for a long time, but still, there's still reluctance towards the change towards IPv6. I mean, the operations teams, even the engineering teams, are reluctant to treat IPv6 the same way as they do IPv4. And it's 2021, and we still hear turn off IPv6 when things go wrong. This shouldn't be a thing, but it still is. So how can you make the correct choice? So there's two ways to go about it. There's the wrong way to go about it, and there's the slightly less wrong way to go about it. The wrong way to go about it is just, produce arguments like, oh, MAP-P makes more sense than MAP-T, or, it feels right. Why? And also, let's not spend a little bit more time on the CPE development, because, time is of real essence in an ISP environment. Everything is critical. Everything needs to be done by today. And same goes with money. Money, let's not try to spend a lot of money on the CPE development. Let's just put in the really very basic stuff just to get it working, and we're good to go. And also, let's just keep it under the radar. I mean, management don't care about it. They don't need to know much about the project. I mean, if they don't, they let us do our job. Isn't that how it is? No, it's definitely not. So the slightly less wrong way to go about this would be to actually research all available transition methods in depth, and that really requires a lot of time and effort put to it. We did do quite a bit of research, but not in depth. And then you have to find the best fit in the network, in your network. Having worked for an ISP for many years now, I can safely say, and you probably all already aware of it, that there's no two networks that are alike. So you really have to find the best fit. And the CPE must really be future-proof. A lot of work must be put into the CPE development by either you or the vendor. And management really needs to be engaged. They really need to be made part of the journey. They really need to know of all the importance of the actual project. They need to know of all the struggles. So what about MAP-P? This isn't a crash course on MAP-P. People need more information about MAP-P, they can look it up. But as per the RFC 7597, MAP-P is a mechanism for transporting v4 packets across IPv6 networks using encapsulation. And it also is a generic mechanism for mapping between IPv6 and IPv4 addresses, as well as ports. Hence the A+P, address plus port. What are the components, or what the important stuff in MAP-P? So you have border relay, which receives the IPv4 traffic from the internet, encapsulates it into IPv6 and sends it back to the CPE. And of course the other way, where the CPE sends IPv4 over IPv6 traffic towards the BR, which then decapsulates it and sends it over to the internet. There's a CE function, the map CE, which is basically a NAT44 plus encapsulation. So the packet, the IPv4 packet, is NATed using a public IPv6, IPv4 address, which is being magically provisioned by a provisioning mechanism such as DHCP-v6. RFC 7598 exists, which describes all the relevant DHCP options, not just for MAPI, MAPT and lightweight 4/6 also. So if we just take a look at the very simple diagram, you have your IPv4 internet on the right, the MapBR in the middle, and the MapC on the left, the DHCP server, and you have a configuration repo, which is not something essential, but it's, you know, it helps if you have one. And what happens is that you get you provision configuration to the MapBR and the DHCP server. Just excuse me. Please excuse me for 1 second. Just need to quit something. Okay. Okay, sorry about that. Yeah, okay, so what was I saying there? You provision the relevant configuration to the MapBR and the DHCP server, which will then in turn provision this to the MapC. And what sort of information does the BR and the C need to know? They need to know the BR address endpoint, which is IPv6, the IPv6 and IPv4 prefixes, plus prefix lengths, and some information about the port range that will be used by each user, because each user is provisioned with public IPv4 address that they can use, plus a port range that they can use with it. And since this is a deterministic way of producing this information, the BR will produce the same information as the CE, so it knows how to forward the packets to the relevant user. What the building blocks in our case? We use the ISC DHCP, the latest version, and we use our BNG just as a DHCP proxy. We have two locations which are in kind of an active standby mode. And when I say kind of an active standby mode, well, the configuration and the actual bindings are synchronized between them. They both announce the same endpoint, IPv6 endpoint via BGP, and one of them is preferred in our network. So if the preferred one goes down, then the other one will take over. It's not 100% seamless, but it does work. We have two MapCs out in our network. We provision 4 different CPs to our customers, like the officially supported ones, and 2 of them, which represent and account for at least 90% of the total number of CPs deployed, have the MAPI feature developed for them. We have the user selection and provisioning is done also automatically. We have scripts that select users to be provisioned with the MAPI service. The main criterion here is that the user is a CGN user, because our main goal is to offload our CGN. We also have a configuration repo in order to feed the DHCP and the BR. This is a GitLab repo, and we use some Ansible too. And finally, we have 2 Cisco ASR 99s acting as our MapBRs. They are deployed in an Anycast fashion for now, and I'm saying for now because there are some issues, some corner cases when you deploy many BRs in an ACAS fashion. But okay, I mean, for now, that's how they're deployed. The BRs are dedicated, even though at first we were going for shared shared function along with our the usual DC router function that they perform. We had to use dedicated boxes because of some limitations that Cisco has. And finally, the map domain. We don't use one map domain. We use one map domain per BNG. We have about 128 BNGs, so we have the same amount of domains. The initial deployment was, I mean, the initial trials were successful. We're talking just about small batch of 20 users, some volunteers, some internal users. And then we started, I mean, since we saw that everything was working out fine, and we let those users try out the service for a few weeks, then we started rolling out small batches, like 500 users per batch at first. And if users, I mean, if our customers complained, there's a rollback mechanism in place which is implemented for our support operators to use it, whenever there were complaints. So the initial percentage of rollback users was actually smaller than CGN's. So we thought that these were some good news, but things started to change a bit later. As deployment progressed, this percentage started to increase, and the complaints started to become a little bit louder, and we started troubleshooting the cases that were presented to us. I mean, at first we thought that they were unrelated. They were just, customers couldn't browse specific sites, but each one couldn't browse a different website. It's not that it was a common website for all. And then other customers couldn't attach large files. But then we found out quite a few users that were unable to use their POS machines, and that was a bit of a problem. Also, some users couldn't access their VPN services, and during a pandemic, this was also a big problem. So we started to think that maybe it wasn't unrelated after all. So after a while, it took us a while to realize, to get to the bottom of it. But here's what the problem was. This is a very simplified diagram of the network. You have from right to left, we have the IPv4 internet, our upstream provider, our edge router, the MapBR, the BNG, and the MapCE. The MPU size between our upstream and our edge router is 1500, and the MPU size inside our map domain is 1492, which means that any IPv4 packet larger than 1452, when the BR would encapsulate that packet into IPv6 and add another 40 bytes, then it would be more than the MTU size on our map domain, which is 1492, as I said, and the BNG would have to drop the packet and send back a packet to big message, which the BR would happily ignore. That was the first thing we noticed. That was something that we solved quite easily. I think it was just a case of MTU path discovery not being enabled by default. So we did enable the MTU path discovery on the BR, but still we didn't get the packet toward the destination, and that's where we started engaging Cisco more and more, and we had a lot of troubleshooting sessions with them, and finally realized that the BR was not handling those packets. They were getting lost somewhere between the fast and the slow path. But finally, Cisco did manage to produce a path that would take those packets and fragment, that would fragment those packets and send them back to the destination. But unfortunately, this could only be true for a limited packet rate, because those packets, as mentioned, were being punted, and now we were violating the control policy, the control plane policy of the box. So we could only get a small packet rate of those packets, and the solution would really not scale at all. We would need a lot of boxes, so that was a no-go at the time. So yeah, it's just an intermission to just remind everyone that the RFCs need to be read and studied carefully. It is mentioned that it's strongly recommended that the MTU inside the map domain be well managed, so that no fragmentation occurs within the boundary of the map domain.
And it's about 2 minutes left.
Okay, so the solution that we're trying to implement right now is to increase the MTU to 1540 inside the map domain, and that's not as easy as it sounds, because there's a lot of layer 2 equipment between the BNG and the MAPC, and we have to check them, or and a feature needs to be developed for the CPE, and we have to investigate the possibility of having different MTU sizes on the CPE between dual stack and MAPI subscribers, so that problematic subscribers can return to the MTU that works for them. So what did we learn? Not too many things, just very quickly. When procuring a new CPE, try to include as many mechanisms as possible, and try to use RFC 8026 for prioritizing those mechanisms. For the CPE, you always have to assume that the map algorithm will be implemented incorrectly, definitely, each and every time. Extra attention should be paid to the MTU across the map domain, and the provisioning and the rollback should be automated as much as possible, and take care of your MTU. One last thing that we learned is that people are not very open with their implementations. I personally try to contact at least 3 ISPs that are known to have similar deployments. I didn't get an answer from any of those, unfortunately. So basically, I'm just going to end my presentation with a call for collaboration, and a question to you all is to basically, how can we fix this? Thank you very much.
So I guess we have a few questions in the Q&A section. Would you mind answering them?
Sure, of course. Just reading the first one from Blake Willis. What was the driver that pushed you to switch from MAP-T to MAP-E? Services, modular. Okay. We only ever tried MAP-T in a very, very brief trial 6 years ago, as I mentioned. So we didn't really switch from MAP-T to MAP-E. When the time came, and after we had tested both in the trials, we just went with MAP-E because it felt right. Sorry about that. Another question from Jan. What were the top 3 operational issues with light? The CPE, actually, yeah, the CPE and the AFTR. The problem is that the AFTR couldn't scale well to a large number of subscribers, and the vendor couldn't put up the extra development effort because there was no interest from other operators. So that's the top 2, but I can't remember a third one right now. A question from Richard Patterson. Could you tell us more about the issues with Anycasting the BR? Oh yeah, yeah. Well, issues is that you might get sent, for example, an ICMP-v6 packet too big might be sent to the wrong BR if it's Anycasted. And about the policy-based routing, yeah, since MAPI is implemented as a policy-based routing mechanism in Cisco, Cisco only limits you to a specific number of PBR that you can implement on the box. I think it's either 1 or 2 per direction. That's the limitation. And okay. Question from Jody. Slide 24. I think it's lessons learned. You talk about S46, 8026. I think it's much better to use 8585, which includes also support for 464XLAT. Good point. Very good point. I've got more success in several broadband deployments, GPON, DSL, cellular, broadband, and just cellular than all the other options. Thanks, Jody, for that. Working now in a deployment for 25 million subscribers, slowed down because of COVID. Thanks for the suggestions, Jody. Question from Sia Satpur. Thanks for the presentation. That was too technical for me. Sorry about that. However, regarding activation of IPv6 and use of stimulation, I think that the major role and responsibility for the support for the use of IPv6 lies with the government. In the Netherlands, the highest ICT policy body of the government has decided that all digital Dutch government must be accessible through IPv6. That's great. By the end of 2021, that's even better. I am curious how the role of the government in Greece or other parts of Europe simulating the industry. Okay, I can only talk about the Greek government. It's not too far behind, but it's a little bit behind. We as operators are operating part of the governmental network, so we are trying to push IPv6 as much as we can. I'm not aware of a government-specific initiative at this point from Greece. And finally, one more question.
Yeah, if you could be very quick, yeah, because we're running out of time slightly.
Yeah.
So the last one.
One more question from Kostas Orbadelos, which is an ex-colleague, and we did the Lightweight 4over6 together. So after all this experience, would software mechanism be the way to go, or could we just stick to CGN for the V4 part in dual stack deployment? Great work and best regards. I really do hope, I really do hope that software mechanisms are still the way to go. Thank you very much.
Okay, thank you very much, Yanis. So next, Paolo, would you like to present, I guess?
Yes, so let me just check if I'm able to share my preloaded slides.
Should be there.
Okay. They are not working, so just 1 second. Okay.
Yeah, it is being loaded.
Share. Okay, so now you should see my slides.
Yeah, all good.
Okay, good. So, good morning, everyone. My name is Paolo Volpato. I'm with Huawei Europe. And by the way, I will present on behalf of the different co-authors you will see listed in my presentation. So before we begin, let me thank the chairs of the IPv6 Work Group for having accepted our proposal to present the results of this analysis that we started around a year ago on the status of IPv6. Since the beginning of our work, we have been involved in some activities, and one of them is the publication of a draft at IETF dedicated to the status of IPv6 deployment, and I will reference the draft in a minute. So, moving to the agenda. Okay, so I will just introduce the draft I've just mentioned. Then I think we will enter the biggest part of the presentation, which is dedicated to the findings of our analysis. And based on our understanding, I would say there are two main findings. First one, the numbers of IPv6 seem relatively good, to an extent that we see, let's say, the importance of what we have called the IP service layer, the layer where we have both the endpoints of a connection, the user terminal and the content. It seems that we are ready to speak of the IPv6 service layer as an enabler for the transition to IPv6 only. Clearly, there are still areas which need an improvement. There are open issues, and that will be the part of the final part of my presentation before moving to the Q&A session. Now, I've just mentioned the draft. You see the name on the title of this chart. So the initial proponents contributed to an ETSI white paper. You see referenced as well on this slide, and then decided to move to IETF to, let's say, bring it to a more technical layer. The intention was to update an old RFC 6036, which is more than 10 years old, about the status of IPv6, identify what is missing for the transition to IPv6 only, and other motivations. We presented the draft at IETF 109 for the first time, and after IETF 110, it was decided to adopt the draft as a work group draft. The reason was mainly because there was a lot of mail exchange on the mailing list. So we had a lot of an intense activity. Several ideas came up. We opened space for many more research, let's say, activities. And that was also, let's say, the trigger to come and present our work at RIPE. By the way, you see the list, the full list of the co-authors of the draft listed at the bottom of this chart. Now, some early indications. As I said, the numbers of IPv6 seem good. We're going to see them in a minute. We see, and there is a consensus, let's say, at least looking at the mail activity at IETF, that the connection endpoints, as I said, the user terminal on one hand and the content on the other end widely support IPv6. As such, we can say, we can speak of native end-to-end IPv6 connectivity. And that connectivity stays at the IP service layer. As I said, one of the ideas that emerged during the discussion is that if this is true, probably we have to look at the IP service layer. Sometimes it is referred to as overlay, as the enabler for, let's say, moving further in the transition to IPv6 only. Why that? Because there we find a lot of transition mechanisms available. A couple of them are listed here for 64X-LAT and DS-Lite, and it's not by chance that we have put those two specific technologies there. They will be referenced in the next slides. And thanks to the availability, thanks to the fact that those mechanisms are already deployed worldwide, probably we are ready for the introduction of more services based on an IPv6 transport, on new applications. Clearly, even if probably most of the work has been done, something still remains to be completed. We have to think about how to move forward in the transition. And here, let's say there is a kind of question for the community. So your feedback is welcome to identify what is missing, what could be, let's say, the solutions to the open questions that are listed at the end of the presentation. Now, quickly, numbers. So you see that the ratio between IPv6 capable users and the total internet population is growing over the years and is probably growing quite well. So if the ratio is between IPv6 and the total population is more than 1/4. And what is specifically interesting is the compound annual growth rate. You see that it is 10 times higher for the IPv6 population if compared to the total internet population. By the way, those numbers have been processed taking into consideration the distribution reports by Dr. Jeff Houston and the EPNIC team. So you see they are the references. That for the user, so the first end of our connection. Moving to the content, probably the here the status is a bit more, let's say, difficult to be, let's say, fully understood. Why am I saying that? Because if we just look at the numbers, we have found these statistics from W3Techs. At the January 21, less than 20% of the websites worldwide support IPv6. If you look at the details of the analysis, they took the top 10 million websites worldwide, and they have analyzed whether there is support for IPv6 or not. But there are other analytics available. For example, one from Cisco Sixlabs shows that if you restrict the analysis to the top 500 websites worldwide, 40% of them support IPv6 first. And second, that group represents the players that provide most of the content. So we are speaking of the hyperscalers, Amazon, Google, Microsoft, Netflix, whatever. If we consider that there are analyses showing that just considering Facebook and Google together, they provide more than half of the traffic, of the mobile traffic worldwide, well, probably the greatest part of the content is available on IPv6. There was a hypothetical question on the mailing list asking what happens if we shut down overnight IPv4. Does the IPv6 based content survive? And let's say the consensus, so the answer, as I said, purely hypothetical, is that the content should survive on IPv6. Then moving on with numbers, we have just let's say processed again the same source, just looking at how we are in the RIPE region and specifically in the European Union. I think that at the RIPE community, there are even more granular data, but just to have let's say a quick look at where we stand, you see that looking at the European Union, we are on par to the worldwide progression. Looking at the wider RIPE region, well, probably we are a bit behind, a bit lower, showing that maybe there is a space for further actions to push IPv6. Now, there are a lot of sources where you can find even more information about the deployment of IPv6. They are listed here. In addition, we developed two independent polls that we submitted. The first one to the European operators, to a good bunch of the European operators at the end of 2020. And there was also another survey developed by the Industry Network Technology Council and submitted to a group of large enterprises, mainly in North America. If you look at the draft, you see you will find all the related information, but just to look at some findings, you see on the left the status of IPv6 in large enterprises. You see that, let's say, the result is not so good, or at least not so exciting. Most of them have not deployed any IPv6 box. In many cases, the engineering department underwent only some basic trainings on IPv6, even if, let's say, the presence of IPv6 devices is good, and in some cases we have, let's say, IPv6 in several places. On the right-hand side, you just find one of the answers from the European operators. Let's say that 80% of them do have plans for IPv6. And for those who are running IPv6, you see the situation, which is represented by the two pies on the right. The first one, top right, is the deployment of IPv6 in cellular networks. The one bottom right is IPv6 in wireline. And you see that dual stack is the main technology considered. And for those who are already moving towards IPv6 only, 4664 XLAT is the preferred technology in mobile, DS-Lite in wireline. Now, why that? So the reasons to move to IPv6, there are several motivations. Depletion of IPv4. There is also one point of attention. Operators do not want to use private IPv4 addresses. There are business motivations. So 5G, IoT are the most referenced technologies or applications requiring IPv6 because of the lack of available addresses. But there are also, let's say, business motivations for that. For sure, saving the cost about NAT, but here the debate is open because it depends on the amount of investment of CDN. And we heard from Yanis before that this is a key point for an operator. There is also some push from, let's say, the regulatory side. Entities who push for the deployment of IPv6 in specific countries, USA, China are two examples. And there are also examples of, let me call it moral suasion to move forward with IPv6 specific as a requirement for assigning a 5G license. And this is an example coming from France, ARCEP. Practical suggestions to move to IPv6 only. An operator that starts this journey in general has to face two steps in this transition. The first one is the introduction of IPv6, and we have seen in that case the preferred technology is dual stack. It's quite simple. There are also a lot of documents helping an operator or even an enterprise to deploy dual stack. The second step is IPv6 only. Sometimes it's also called IPv4 as a service. In that case, let's say the pre-requirement is that the network should move to IPv6 as well. But again, here the debate is also open because clearly that cannot happen in a very short time frame. So there is more space, but let's say the second step is the one who, let's say, grant us that we are really moving to IPv6 only. And as I said, the IP service layer is playing a role here. If you look at another analysis, which is different from ours, and that was conducted probably 2 or 3 years ago, you find the reference just to look at where you can find the original source of data. That is the situation considering the deployment in a real network. So on the left-hand side, you have the technologies used by mobile carriers. On the right, those used by fixed carriers. And once again, you see that the results are confirmed. So an operator either deploys a dual stack for the first step in the transition, or consider other technologies, and the preferred ones are 464 XLAT for mobile and dual stack light for fixed. Now, clearly, there are open points. There are areas for improvement. Now, it's not my intention to go through this table so that we can save time for the discussion, but just focusing on the operators area. We have seen that many comments in the mailing leaks were okay. For example, for fixed operators, there is a consensus that it's good to move to IPv6 only, but they have to consider the installed base. They would love to move to some transition technologies to deploy that, but there is, let's say, the point of granting the return of investment on what has been deployed so far, and that is specifically associated to the role of CGNet. Another point, they have to wait for the update cycle of the CPEs, which are considered another point of attention, at least, for moving to IPv6 only. As far as mobile operators are concerned, there are other types of problems. Probably they are a bit ahead if we compare them to fixed operators. In some cases, the regulation has a positive effect, is a push to move to IPv6 only. There is currently a debate. Where is the right point to move from dual stack to, for example, 464 XLAT? Is there a matter of reaching a certain threshold of IPv6 traffic volume? And as I said, the question is open. And by the way, we would like to hear from your experience if that is the case. There are other stakeholders, enterprises, cloud and content providers. I just highlight that, for example, the community highlighted even the CPEs have issues because many of them support IPv6 for sure, but there are exceptions. And smart TVs, set-top boxes, consoles are examples of not complete, not widely support for IPv6. And for sure, many of the respondents of the poll, and that was also highlighted in the mailing list, show that there is a role for regulation. Now, moving towards the conclusion of the presentation, there are perceived open issues. Just to name a few of them, probably the most important, network operations. There are a lot of misconceptions. IPv6 is complex to be deployed. Performance. In general, people tend to compare IPv4 versus IPv6, and when the result of the comparison is not good, in general, the behavior is that, okay, so IPv6 is not good for me, which is not true. Security, which is also perceived as a critical area, and many people tend to think that is very complex. So we gave this slide the title "A Call for Action" because really we'd like to have your feedback on those points. If you have analysis, best current practices, even tools that could be referenced by our work, that would be great, and we would be happy to listen to you. So concluding the presentation, basically what we have found. IPv6 is growing quite steadily, so the growth is good. IPv6 has a value for all the industry players. In general, deployment is handled considering 2 stages. As I said, there is a role for regulation to give a push, to give a support to the transition to IPv6. Clearly, there are challenges, and we have seen the areas where challenges apply. And as I said, there is an open question, and we'd like to hear from you. Is there a threshold to move from IPv4 to IPv6, and specifically to IPv6 only? And I will say that I stop here, so I leave some time for questions. Thank you.
Thank you very much, Paula. I think we have one question in the question section, and we have 2 minutes. So if you could answer that.
Yeah, so I see a question from Christian. Many don't find any business reasons to adopt IPv6. Did you find now any business reasons to adopt IPv6? I think this is one of the most interesting and critical questions. I'm sorry to say we don't have a definite answer, because that is also part of the discussion. In some cases, business reasons do exist. So if you look at the poll, spend time maybe reading our draft and providing comments. Some of the operators that moved to IPv6 clearly stated it's a move for the future. We need to be open, let's say, to innovation. It's for enabling new applications, even if those applications are not, let's say, available now. And there is let's say, a kind of consensus that probably 5G and IoT are 2 cases for something demanding IPv6. It's not completely true. Some other operators have a slight different opinion, but that could be, let's say, the main reasons. There is another motivation, which is probably not clear yet, but it is the role of governments and, as I said, national authorities' actions in favor of IPv6. There are cases, 2 of them are USA and China, where federal agencies, governmental agencies have begun to demand not only the support of IPv6, but probably to have just IPv6 based applications. That is the current status. Yen, I see there is another question. Do you want me to answer?
Very quickly, very quickly. Oh, Veronica, yes, please
Veronica,
answer, and we're closing the line.
Okay, so very quickly, just the common introduction of IPv6 does not immediately relieve the pressures of IPv4 address pool. Dual stack does not help with this problem. Only IPv6 only does help with IPv4 address shortage. It'd be worth clarifying it on the relevant slide. Yes, let me say that the answer is I fully agree. So we will do that.
Okay, thank you very much for your talk. And now we have the last presentation of today. Jens, you have 10 minutes and you have 22 slides, which make it more than 2 slides per minute. I hope you can make it. And we can't hear you so far. At least I cannot.
Too many buttons. So you can hear me now, right?
Yes, yes.
Okay.
The floor is yours.
So welcome to Berlin. At least Google told me on Monday that RIPE 82 is in Berlin this week. Yeah, so happy eyeballs considered harmful. I recently ran across some problems with happy eyeballs, and I want to share some thoughts about that. So first, who am I? I'm not Jen. Some people confuse us sometimes. I'm a freelance consulting doing IPv6 since 2007, and I'm organizing a monthly meeting for admins in Berlin. Well, right now on the internet, and I come to this in a bit. What is Happy Eyeballs? Happy Eyeballs is mainly implemented in web browsers. It's trying to work around broken IPv6 connections on the internet. It's around since 2011, and some people claim that it was one of the reasons why the big players dared to enable IPv6 at all. How does it work? Basically, it uses both IPv6 and IPv4, prefers IPv6 to start with and tries to connect to the remote server and then chooses the working or the better connection. So what's my problem with Happy Eyeballs? Nobody's noticing that how do you notice that something is broken? And what's the incentive to fix the problem if it apparently works? And what other side effects we might see? People might have heard about Happy Eyeballs, but don't realize what problems it may cause. So, yeah. So one example, and that's from our monthly meeting. University here, where we normally met in real life, has a big blue button for us. Users can only connect via IPv4. And unless you're looking closely, you don't notice. So there's a Firefox plugin, IPv4, you can install, or somebody tested with RIPE Atlas probes. Or you use curl on the command line and you see that IPv6 is not working. The server has a quad A record, routing works, but there's a firewall in place, and the people running the server don't talk to the people running the firewalls, and yeah, that might lead to some problems. Another example, a customer is using IPv6, it's moving to IPv6 only internally where possible. All new websites are dual stacked from the outside. And they had a new site, and while testing, it was only reachable via VPN. And sometimes it works, sometimes it didn't work. And many people were guessing why. One of the main reasons was the VPN currently only supports IPv4. And so IPv4 went through the VPN tunnel, and the browser decided, yes, we use IPv4 now. And other times, IPv6 was used, and users who tested the site got error messages. The short-term solution was to disable IPv6 DNS lookups in Firefox. And the long-term solution will be to set up a new VPN solution that supports dual stack until they can move to IPv6 only in maybe 40 years. Yeah, so you should be aware of Happy Eyeballs and the problems you might face. You should know your infrastructure. If you offer services to the internet, monitor from the outside. That's always a good idea. Try to automate things, or at least have a checklist, a workflow for setting up new devices, new services, and don't use IPv4 only VPN tunnels. So, and maybe someone from the scientific community would like to do some measurements if we really need Happy Eyeballs today. So are there that many broken IPv6 networks or not? And now I'm ready for questions and discussions. And I prepared for the discussion, so I have a big bowl of popcorn.
Fantastic. So I think we have some questions. So there is a question from Jordi in the question section. Jens, would you mind Oh, more questions coming. Can you see them?
Yeah.
Okay.
So Jody, it's not a question, just a statement. Yes, other people see the same problem.
So I may ask you to read the questions out when you're answering them. So if someone is watching the video later, they know what we're talking about here.
I described the problem a long time ago, and that's why I proposed in IETF reporting of Happy Eyeball version 2 failures to ISPs, so ISPs know that something is broken. And he refers to the draft there. I won't read the URL. And then Blake Willis says, to add to Jordy's question, is the community aware of a tool site app that users can use to catalog IPv6 problems, or is the ecosystem hopelessly fragmented too? And there's something in the way. Okay. Can we suggest a browser plugin to show Happy Eyeballs problems like IPv4 ideas? So I'm not aware of a plugin, and I guess it's internal in the browser, and you have to talk to the browser vendors. Don't you think adoption of NEL network error logging is solving this kind of problem? It might be. Is it enabled somewhere? And analyzed if it's enabled? Gerd Döring. Yeah, another example, we saw Apache ACLs were not right for IPv4, I think, and browsers were randomly flip-flopping IPv4, IPv6, and user reports were inconclusive. Any more questions?
Okay.
There was somebody on the audio with audio, but currently
I
can't
think
find out.
Alexander asked his question in the Q&A section.
Okay.
Okay, so
that's for me.
perfectly on time. Great job, everyone. Thank you to everyone who presented, everyone who participated and asked comments. Please rate the talk so we know what to bring for the next session, next year. So thank you very much, guys. See you in when? Soon. Yeah.
Right.
So now let's get this ready here. Hey, what is that? It looks amazing. Let me see, can I fit in here? Welcome, everybody, to the Ripe 82 Kahoot quiz. My name is Gerardo, and I am your quiz master.
Good luck.
You will need it today. We are broadcasting today from an IP packet traveling on the internet with infinite time to live. So, whee! This is fun. The topic of the quiz today is Ripe Labs.
Oh, here comes trouble.
No, this is no trouble at all. And today's quiz is sponsored by IPXO. So, in case this is the first time you've played this game, let me tell you how we're gonna play it. It's no laughing matter, by the way. I'm going to show you a couple of questions, 10 to be exact, or 11 maybe. And then you're going to have some answers, which you can choose. There are 4 colors, red, green, blue, and what's the other one? Well, and another color, red, green, blue, and yellow. Aha! And you just have to choose one of those 4 colors or the right answer. It's better if you choose the right answer because that gives you the most points. And so once you've chosen your answer, if you're the fastest one, you're going to get the highest points. Okay? Sorry, my IP packet is just speeding down the internet highway. It's 10:46. And I think it's time to start. So grab onto your hats, grab onto your keyboards, and let's play the game. So, first of all, the first question is about Ripe Labs, of course. True or false? You have opened Ripe Labs as I speak. You have 20 seconds still. Have you opened Ripe Labs as I speak?
Ouch.
Yeah, I stumbled over something. Anyways, this isn't really a question. This is more like a request. If you open Ripe Labs as I speak, you are actually going to be able to answer some of the other questions. So we have half the people who open it, half the people who don't. Well, anyways, you can still open it up. Now, Ivana Tinkle at the head, Laura 270, Vista 676, Windows 95, and Stucky Max. On to the real first question about Ripe Labs. During your time as Ripe Labs editor, how many comments did Miriam Kunye leave on Ripe Labs articles?
Why not?
Yeah, why not? Leave a comment on an article if you can. So, was it 1,132? Was it 3? Was it 107? Or was it 43? One of these 4 answers is the right one. And if you think that it's 3, you're wrong. The right answer is 43. And that is the amount of comments Miriam Kunye left on Ripe Labs articles. If you had Ripe Labs open, you could have counted them, actually. So, Ivana Tinkle falling down, C588 at the top, Truber 176, 479, Philip, Ivana, and Laura 270. Next question. What year did BGP meet CAT? So what year did BGP meet CAT? That's right, Fido. It was that year. 2017, 2016, 2018, or 2019. One of these 4 years is the year that BGP met CAT. And if you don't know what we're talking about, it's that time that the cat was drawn with BGP. If you don't know about it, you can look in Ripe Labs. The right answer is 2017. And let's check the scoreboard. Cherber 176 taking the lead, Philip 479, Stucky Max, Rolf 716, and C588. I love those codified names. And on to the next question. LA, B, and S. or LaBS? These are the chemical symbols for which elements? Is it lanthanum, bromine, and sulfur? Is it lawrencium, boron, and sulfur? Is it lanthanum, boron, and sulfur? Or is it lawrencium, bromine, and sulfur? If you can say all those elements together quickly, you're probably insane. And the right answer is lanthanum, boron, and sulfur. This answer was probably somewhere on Ripe Labs, and you could have looked for it if you would have done a quick search. On to the next question. Stoogie Max taking the lead. C588 coming up. Cherber 176, Vista 676, and 479 Philippe. That's right, Alien. That was a difficult question. Who wrote the first ever article to be published on Ripe Labs? Was it Vesna Majnorovic? Was it Daniel Karenberg? Was it Miriam Kuhne? Or was it Robert Kistelecki? The right answer, if you remember, if you were an elephant, was Daniel Karenberg. He wrote the first ever article to be published on Ripe Labs. And let's check the scores. Stoogie Max still at the front. Cherber 176, Elvis Villa coming in with his number 624, C588, and Windows 95 trying to reboot. On to the next question. What is hot according to the title of Melchior Eilman's 2018 Ripe Labs article? Is it the Ripe meetings? Is it routing security? Is it cybersecurity? Or is it the Ripe community? One of these four is the right answer. If you don't know, just press a random button. You'll get the answer at the end. So what was it? Routing security, cybersecurity, the Ripe meetings, or the Ripe community? And the right answer is routing security. That is what's hot, according to the title of Melchior Eilman's 2018 Ripe Labs article. On to the scoreboard. Stoogie Max still at the front. Elvis Villa coming in close. Cherber 176, C588, and Jurian 264. Next question. Dolly the sheep was the first mammal cloned in a lab. What breed of sheep was she? If you don't know this, you might be able to find it where? No, not there. But in any case, was it Hebridean, was it Hampshire, was it Finn Dorset, or was it Cheviot? One of these four types of sheep was Dolly, and it is the Finn Dorset. I didn't know that either. And let's go to the scoreboard. Stoogie Max is burning. He's still at the top. Elvis Villa 624. Ivana Tingle coming in 479. Philippe and Vista 676. So, how many Ripe Labs articles has Emil Abben written? Is it 201? Is it 9? Is it 93? Or is it 7? You cannot choose more despair number than this. Was it 201? Was it 9? Was it 93? Or was it 7? One of these four numbers is the right number, and it is actually 93. If you had Ripe Labs open, you might have been able to find that answer really quick. Scoreboard, Stoogie Max taking the lead by force. RVS 222, Philippe, Windows 95, and Vista 676.
I love you.
I love you too. But we have to continue with the quiz. Fergal Cunningham made his debut on Ripe Labs in 2010 talking about which topic? Was it football? Was it Uzbekistan? Was it skydiving? Or was it Ripe Atlas? That's right, Fido. Only the cow knows. That's right, cow. You do know. What was the answer? Ripe Atlas, football, Uzbekistan, or skydiving? And the right answer was football. Foolish you people that thought that Robert only wrote about Ripe Atlas. And I made my big first blooper. Stoogie Max still at the front. 479 Philippe coming in close. Vista 676, Ivana Tingle, and RVS 222. You still have 2 chances to take the lead. How many Ripe Labs authors have written articles that use the tag BGP? Is it 21? Is it 29? Is it 66? Or is it 0? So, is it 21? Is it 29? Is it 66? Or 0? One of these four numbers is the right answer. And if you choose 0, the right answer is 21. So if you would have looked up the tag VGP, you could have counted those 21 articles in Ripe Labs. Stuggy Max, still at the front, taking quite a leap. You'll have to disconnect him if you want to win. RVS 222, 479, Philip, Vista 676, and Ivana Tinkle.
Yeah!
On to the last question. Athena Fraculi kicked off a new series of Ripe Labs articles in April looking at what and policy-making developments. What and policy-making developments?
Oh, yeah!
Was it artificial intelligence? Was it GDPR? Was it Greece? Or was it ancient philosophy? You have 20 seconds to search in Ripe Labs.
Good luck.
It's actually really fast to find stuff. But the right answer will come in 3, 2, 1. Boom! Artificial intelligence.
Are you crazy?
Not at all. That's a great topic to do an article on. Now let's check the final scoreboard.
Are you sure?
I am totally sure. And the podium on place number 3, we have Ivana Tinkle. Number 2 is 479 Philip. And number 1 is, surprise, surprise, Stuggy Max. Congratulations, Stuggy Max. You have the fastest fingers on the planet, at least for today. Thank you, everybody. The topic of the quiz today was Ripe Labs. We hope you had fun and played the game. Tomorrow we'll be back for our final quiz, and we want to thank you, our sponsor, IPXO. Enjoy the next Ripe 82 session and have a great day. And remember, stay safe and stay sane.
Yeah!
Hello? Constance, can you hear me?
I can. Can you hear me?
Yes.
Awesome.
So will you be sharing the agenda?
requesting to share my screen.
Can see the screen. Yeah.
All right, shall we start?
It's 1, I think. We can start.
Okay, then. Hi, everyone. It is so not nice to not see you again. It's good to not hear anybody sneeze or cough or breathe, though. So anyway, I'm still very happy to be here. And first of all, want to thank all the people that are persistently and successfully making these meetings happen despite the obstacles we currently still have. And with that, welcome to the IoT working group session. Sandosh and I have prepared a cute little agenda for you, starring housekeeping, as well as announcing who's going to share that screen space with me the next time around. Then we've arranged for 2 talks. Saeed from the Max Planck Institute for Informatics is going to present his work on scalable detection of IoT devices in the wild. And Natasha from the Canadian Internet Registration Authority is going to give us insights on what an IoT registry might be good for. Afterwards, I'd like to present a few results of the IoT working group survey and start a discussion, which I hope will have to be continued on spatial chat afterwards, because I really don't know what I was thinking when I reserved only 10 minutes for that whole thing. Anyway, housekeeping. Here's all the information you need. So out of order, you can use the group chat to communicate with other participants, which you can see in the participants list. If you want to ask a question to the presenter, you can do that by using the Q&A window and have Sandosh handle the talking part, or you can use the audio queue, and if you want, also share your webcam video to have the most immersive experience. That said, be aware that the session is being recorded and will be published on RIPE 82 archives together with the chat logs, by the way, so please be nice to each other and especially to our speakers. All right, and if you could state your name and your affiliation, if not otherwise indicated, that would be great. So what's next? I'm going to show you a little preview of what the RIPE 83 slides are going to look like. Huh? Why? What? Well, consensus on the list was that Sandosh shall remain co-chair of the IoT working group. Congratulations, Sandosh.
Thank you, Constance. As I mentioned earlier, I stood for the second time because I thought that the things that we wanted to happen at IoT group is not yet complete. Even though it is not complete, I could say that I have been participated at the first IoT hackathon team and also preparing the RIPE IoT BCOP document. So thank you everybody for having me the second time. Thank you. Thank you, Constance.
Yeah, and also thanks to Peter Steinhäuser for standing. I think it's really cool to see that engagement. And on that note, both Peter and Sandosh, as well as Elliot Lear, Michael Richardson, Phil Stanhope, Jelte Jansen, and Jan George also deserve a shout out for their work on their document, Architectural Considerations for IoT Device Security in the Home, which meanwhile has been published under RIPE 759. It's a document that, as the world changes, is likely going to be edited or extended once in a while, and I suggest that if you haven't already, to have a look. Okay, you have about 10 seconds to applaud for them now, while I give word, screen, camera, all of that to our first speaker, Saeed.
Okay. Can you hear me?
Yep.
Yes, we can hear you.
One moment. Let me share. Okay, so I think there is an issue with my sharing system. Let's use the pre-uploaded slides. Okay. Yeah, hello. Thanks a lot, Constance and Sandoce. I'm very happy to be here. Hi, IoT or RIPE community. I'm Jawad Saidi, and today I'm going to present our work on scalable detection of IoT devices in the wild. And this was a joint work with Northeastern University, TU Berlin, Max Planck Institute, and Imperial College London. And I would be very happy to have your feedback and comments as well. So we all know that IoT devices are very popular these days, and also there is a lot of security issues has been reported by them. For example, the Mirai attack, and also you know that these devices are cheap, and so there are some security issues with the cheap devices that come into play. And the question is, okay, so with all these problems, we were curious, can we identify and locate devices in our networks? And so we had this problem can be studied in different environments. And we had a collaboration with a large European ISP. And we took this challenge and thought, how can we perform this task? And the question is, why should we do it in the first place, and where can be used where can this be used in context of ISP? So it has multiple benefits. For example, this can, as an opt-in service for ISPs, can be used for the benefit of the customers. For example, if one of the devices that get infected or get compromised and participate in large attacks, or we can notify the customers about it. And also, if, for example, a device is again participating in an attack or compromise and there's a security issue with it, we can also go ahead and find what other subscribers of an ISP might have the same issues. And there has been work that showed that in aftermath of Mirai attack, ISPs engaged in the activity of notifying customers by various means, from sending email, calling them, even they went to the extent of redirecting their traffic to this page and telling them, hey, you have an infected device at home, please do something about it. So, but in any case, if you want to perform an IoT device detection at the scale of a provider, it's not an easy task. Because, as we said, there are a lot of them, different type of devices, and there were some works that suggested we should deploy some scanner or agent inside the premise of each customer, and it starts scanning. But this is not scalable and it's very privacy intrusive, and we have to make sure that we don't infringe the privacy of our users. And there's an active measurements. If we want to send probes and see what device is at home, it won't work, especially when the devices are behind the NAT. And also, we cannot do deep packet inspection to perform this because of, first of all, the privacy concern, and also about the scale and the amount of data that we have. In this sense, the question is that which data source we can use. And so we have providers are already collecting net flow captures or flow capture utility, flow captured data for their other operational purposes. But these data sources are sampled; they don't have payload. They contain only the headers. So so can we use, the question is that can we use these data sources can we detect IoT devices using limited passive and sparsely sampled flow data? If yes, at what granularities can we do that? And how fast can we detect IoT devices? And how are IoT devices deployed today as observed in flow data? The key insights of our work is that devices that we studied showed repeating patterns of communication that appeared even in sample flow data. And the detection rules, we generated patterns and detection rules that can, using these limited fields to detect devices. And of the studied devices, we were able to generate patterns and also apply these patterns that resulted to detection of 77% of studied IoT manufacturers in a large ISP, and the European ISP and ISP as well. So how do we perform that? The key insight of our work is that here we have an ISP, and this ISP or service provider has different customers, and each customer may or may not have some sort of devices. And these devices, in order to provide their services, they have to communicate with certain backend infrastructure in the internet or servers. And we said, okay, if we focus on the destinations and contacted by these IoT devices and characterizing these destinations, can we find which subscriber has which type of device? And next, I'm just going to quickly outline our methodology, which contains 5 parts. First, we had to generate IoT traffic, and then we have to check whether we can see even the traffic of a single IoT device from a single vantage point in NetFlow or at the ISP level. And then after that, we had to generate or use features that we saw in the IoT traffic, for example, domains, IP addresses, and port numbers, to detect some patterns and to generate some patterns and detection rules. And also we have to cross-check our detection rules to make sure that we are actually able to detect our devices even at our vantage point. And also we applied these detection rules on the devices, on the NetFlow data from ISP. Okay, so the first step was generating lab traffic or ground truth IoT traffic. And how did we generate this? So we set up 2 test beds and containing 56 IoT products from 40 vendors. And they were from these 6 different categories. And we triggered these devices in 2 ways, by setting an idle experiment and an active experiment. In the idle experiments, the devices were just simply connected to the internet. And in the active experiments, we programmed them to interact with devices in an automated fashion. For example, by asking Alexa device or Amazon Echo device, what is the capital of Italy, or what is the time of the day, and so on. And it depends on the functionality of the devices. And during these experiments, we connected our labs to a home vantage point inside the premise of ISP, and then captured the IoT traffic across at home vantage point and also at different locations in the ISP. Next, we went ahead and we wanted to see, okay, can we see even a single traffic from a single device from a single vantage point or not? The gist of it is yes. During here in the y-axis, you see number of devices detected within each hour, and x-axis shows the duration of different experiments that we conducted. And we are comparing the number of devices active or observable at home and number of devices observable in sampled flow data. And we detected activity from more than 64% of devices. And we define activity at this level as at least observing at least 1 packet from that goes to or comes from a device. Okay, and how can we generate pattern or find other subscribers that might have the same, that might host the same type of devices? So the one naive approach is, okay, I have the ground truth or lab IoT traffic, and each device talks to different IP addresses over different ports, and I want to generate detection rules or pattern for each device. So I just look at the same traffic and look for the same destinations in the NetFlow data and say, okay, subscriber 1 has this type of device and subscriber 2 has this type of device. This is a naive approach. The reason is this might result into misclassification. First reason is the partial coverage, and because the IP addresses that we saw in the ground truth traffic or the lab traffic are incomplete, and we might not see all the IP addresses contacted by the devices, and these destination IP addresses that were contacted might change over time. And we also, there's a chance there's a chance that we confuse the non-IoT traffic that we see in the NetFlow data with the IoT traffic, because these IP addresses might belong to some generic services and domains like wikipedia.com or netflix.com. And also, some of these IP addresses go to shared infrastructure such as CDNs, where these are contacted by a wide range of services or users, not only devices, but human activity also is included in those. Human activity is also included in this data. So how can we handle this issue? We use passive DNS data to, and since we already had the lab traffic, we know what are the domains resolved by those devices. So we started with the domains resolved by each device and find out what type of domains, for example, whether this device belongs to generic infrastructure or is it belongs to shared or CDN, and also using the same passive DNS data to find other IP addresses associated with a domain. And we removed domains and also subsequently all the IP addresses that belong to shared or generic infrastructure, and then generated the patterns for each device. So we did check whether we can apply these rules, and we applied our rules on our own data set to see how many of devices can be detected. But in the interest of time, I will skip that part and show after showing that what kind of rules were detected, I will show the result of applying our methodology on ISP data. In the rules that we generated, we had three levels of granularity. One was the product level. In the product level rules, we could only say this is the final granularity, and we say what type of device are we seeing. Is it an Amazon Echo or is it an Amazon Fire TV or not? At the manufacturer level, we cannot say the type of the product, but we can say to which manufacturer does it belong. And at the platform level, we can only say it's a generic IoT device. We cannot comment on the manufacturer nor the product level. And overall, these rules account for 77% of the manufacturers in our testbeds. What happens if we apply this methodology or these patterns in the data from ISP, NetFlow data from ISP? Here, we see again the result of applying our methodology. In y-axis, we see number of unique subscribers per hour. And in the x-axis, we see the duration of the data that were considered. And each point shows the number of unique subscribers that had the specified IoT device by looking on only 1 hour of NetFlow data. And we start with the Samsung IoT and Alexa-enabled device because they were the most popular ones in our data set. And what we see here is by looking at even 1 hour of data, we were able to infer the presence of more than 1 million subscribers with the Alexa-enabled devices. Alexa-enabled device a device that responds to Alexa voice service commands. We also observed some diurnal patterns, and for Alexa and Samsung-enabled devices. What happens if we look or we take into consideration more or longer duration? And here we have again the same plot as we had earlier, but in order to decide whether a subscriber has one device or not, we look into at least for 24 hours, sorry, at most 24 hours of data for that given subscriber. And what we see here is the numbers stay stable, and there is not a lot of variations here. And we see that increasing observation period help detect even more devices. One reason is that these devices talk to their destination domains at different rates. And in overall, we detected activity for more than 20% of subscriber lines in our ISP. If we zoom in on the 32 IoT devices that I showed you in the previous plot, you see here on the x-axis the number of, or each device, in the y-axis in each device, in the x-axis again the date, and each box shows that how many devices detected on that date, or how many subscribers with that device was detected at that date. We grouped them into, for each device we went to Amazon in the country of ISP and see what is its ranking in Amazon, basically in Amazon Marketplace. As you see here, we saw some correlation between the device popularity and the devices that were popular that were in the top 10 or top 100 in ISP in Amazon were also popular in our data set. And for those we couldn't find any ranking, we put them in the other category. And for some of them, we saw only a handful of devices here in our data set as well. And in the end, our methodology has its own limitations. So there are a lot of, some limitations on here. If a device relies only on CDN or shared infrastructure, since we don't have access to DNS data and we only have access to the header information, we won't be able to detect that devices. And if you want to generate detection rules and patterns for a device, we need to study that device. And if the domain names contacted by the devices change, it will also be not easy for us to notice without again going back to the or regenerating the rules. And detection of devices with a small activity. We had devices that were not activated, that were very small activity. For example, smart plugs, and these devices are only mostly generate their traffic when they have when they are triggered. And in that sense, we won't be able to see all of them. And with that, I want to conclude here that we showed a methodology to detect IoT devices based on limited sample flow data. These devices, the rules that we generated accounted for more than 77% of studied IoT manufacturers in our test beds. We detected around 4 million subscribers or with at least one of our devices that were in both popular and not so popular category. If you are interested in the patterns that we have generated, you can go to this link or scan this QR code and have a look into our patterns that we have generated. And if you have any further questions, you can reach me out on these addresses. With that, I would be happy to take questions.
Thank you. Thank you, Syed. An interesting work. We do have some questions in the Q&A session. I will start from the first. It is from Patrick Tarpey from Ofcom. Do you observe any use of encrypted DNS resolvers for IoT traffic?
At least in the data set that we have, in the devices that we have, the devices, they didn't use encrypted DNS resolvers. And of course, there will be an issue here. And for example, if someone wants to, okay, let me put it here this way. If someone wants to apply our methodology using only or capturing the DNS queries, that would be very good. As you said, if the users are going toward DNS query, encrypted DNS resolvers, then it would be hard for the service providers to know what type of device is in their service, in their network.
Okay. The next question is from Jacques Latour from Syrah. He is curious to see if you run a report to look at which country the IoT device connect to.
Very interesting questions. My collaborators had a previous work, and you can just by changing the URL to IMC19, they have shown the countries that these devices talk to, and whether changing or connecting to different ISPs will impact the set of infrastructure that these devices might talk to. So yes, there are some destinations that are outside of Europe and also going even back to China and Taiwan that these devices are talking to. Yes, we have observed that.
Okay, thank you. And we have Marco Hogan Wanning from RIPE NCC. He had multiple questions. I will give you all, and then you can respond as you wish.
Yeah.
In analysis, did you consider the impact of NATs or also local ones? Or are you able to give an estimate how NATs would impact your methodology by bundling multiple devices behind a small set of addresses and ports? And subsequently, he also asks, how would IPv6 adoption impact this research?
Very good question. Impact of NAT, we don't have carrier grade NAT in our in the studied service provider. If there is a carrier grade NAT, then there will be a problem. And second is that what is the impact, or how an estimate how NAT would impact our methodology. So our method, if for example we have multiple devices of the same type behind the NAT interface, then our methodology won't be able to detect, or we will have a stronger signal and it would be easier to detect them, but we won't be able to say, okay, if there are 3 of these devices or 4 of these devices. In this sense, the numbers that we have reported are only lower bound, not the upper bound. So there might be even more, and this is the impact of NAT in that on our methodology. And looking at this, how would IPv6 adoption impact this research? I'm not sure that how thinking on top of my head, it won't negatively impact it, because, or it might to some when I think it might even help, because there won't be NAT, and then we can even detect at a better granularity, or finer granularity. You can say, okay, now the subscriber is not only a single IP address, and assuming that the NAT will go away from at the subscriber's boundary, and each device will have its own IPv6, global IPv6, then it would be even easier for us to dissect it.
Thank you. Constance, I would let you to introduce the second presenter.
Thank you very much. I have also something to add about the questions about the NATs. Actually, first of all, hello everybody. I'm Anna Maria Mandalari, co-authors of this work with Javad. Thank you, Javad, for the presentation. So the NATs, the usage of NATs doesn't impact anything in our work, because for like creating the signatures, what we do, we look at the destinations. So the IP addresses these devices are contacting. So the usage of NATs won't impact anything. The usage of IPv6, as Javad said, will be even better for our research, because, I mean, the methodology will remain the same, but we will have more addresses to use exclusively for the destinations that these devices are contacting. That's all. Thank you for your attention. Thanks, Maria. Looking at the time, I would right now quickly go over to Natasha. It's your stage.
Hi, I am going to just try and share my screen and see how that goes. Okay, so I'm here to talk to you about the implementation of IoT Safe using a registry. So we at CIRA have worked on a really interesting project that focuses on leveraging eSIMs today to extend the use of our registry. Okay, I'm just trying to get my slides to move. So our future internet is evolving. Today, it's just a bunch of web pages and websites that you can access. Our future is really smart cities, autonomous vehicles, smart energy, and a lot of this technology will be 5 or 6G based, but as well as have eSIMs on them. So the role of the registry will expand to not only support what we are supporting today, but as well as supporting these things in the future. So our IoT registry project is really geared towards extending the use of our registry and supporting the internet in that realm. So today, with our internet, we could do a few things with our registry, and that is you can switch between internet providers. So if you want to switch between GoDaddy and Wix, for example, you can do that fairly easily. If you're a coffee shop owner and you sell your business, you can transfer ownership of your domains to the new owner as well. So we're taking these same concepts to the future. Today, a lot of our IoT devices are based on walled gardens. And in order for the smart or the world of IoT to scale, we really need that to have generic providers. So for example, in our smart city, you've got our smart meter. You can change your providers from ParkoServe to CarParkServe. You could also transfer ownership between different cities, for example. And the third thing that we're going to be able to do is actually transfer between mobile operators. So in Canada, for example, you could transfer between TELUS and Bell. And that is something that is similar in concept to what we have today with our registry, but we'd like to take that into the world of IoT so we can move away from the walled gardens. One of the standards that we have started to leverage for this is the GSMA IoT Safe. So although GSMA has the M2M and consumer spec, IoT Safe really brings the whole ecosystem together. It brings the device manufacturers, it brings their service providers together, and provides a way for everyone to talk to each other in a secure manner. At the root of this, we are leveraging an eSIM as a robust, scalable hardware router trust. And what we're really trying to do in this scenario is create a chain of trust within the ecosystem. So what is different about this SIM versus any other SIM? This SIM has the GSMA IoT Safe applet on it. And what it does, it enables this eSIM to act as a little crypto safe where it can generate key pairs, it can verify signatures, and publish a public key. At the end of the day, this is super important because what we're trying to do is create a secure TLS connection. So this is what our registry looks like. You can see that we've got our DNSSEC, we've got our certificate authority, and we've got the server middleware and APIs. And northbound, it talks to the application service provider. So this is the provider in the cloud for the service. For this phase, we have used Solace as our MQTT broker. And our mobile operator is TELUS, and that's using the Tally equipment to provide the cloud OTA, to provide the APIs, as well as the SAFE module. So this SAFE module is what talks to the SAFE applet on the eSIM. We have our cellular module in here, and the IoT device has the device middleware. So we submitted this project as part of the LSpark MedTech Accelerator, where we partnered up with TELUS and Solace to provide a platform for medical devices to continue their innovation. So one of the challenges that we had with this project is that is the middleware, which is why Sierra provided the middleware. And part of what needs to happen is that some of these need to be part of the OpenSSL standards. So that's why we provided the middleware. However, going forward, it's going to be up to the IoT device manufacturer to decide what they're going to do with this middleware, and you know, are they going to be Raspberry Pi based or Arduino based? So the way this works is when an IoT device is powered up on a network. So for example, if it's a tech at the hospital checking to make sure these heart monitors work, or if it's a tech out in the field installing a parking meter, or whether it's an actuator on a nuclear plant, the first time it's powered up, it's got this eSIM on it. So it's going to make contact with the closest cell tower and try and establish a connection with the correct mobile operator. So what happens is the customer will send the EIDs off this device or eSIM to the Sierra registry, which in turn will pass that to the IoT security server, which in turn will pass it to the IoT device. And what it does is it tells the mobile operator, hey, you need to establish connection with this IoT device that has EID 0050, for example. So once that connection has been established, the IoT Safe or the eSIM, the applet, will now send publish the public-private key pair. The private key always stays on the eSIM. It does not get published publicly at all, but it's the hash of the public key that is transferred. So this information in turn is sent back to the registry that adds all the appropriate certs to it, and then we'll send the information to the application service provider and to Solace so that this TLS connection is established. So that is basically, from a technical perspective, how this registry works. And And so in a nutshell, what the registry does, it provides the user or the customer the capability to register their IoT device, to activate the IoT device, to transfer it, and to deactivate it, as well as delete it. So for example, in the MedTech Accelerator that we participated in, some of the companies said, hey, you know, we no longer want to, we've done our development, but we don't want to continue down this path at the moment. And so we're able to just go into our registry and delete those EIDs. So this is really important in the context of IoT devices, because if you start to think about it, there's millions of IoT devices out there in the future, and we're gonna have some of them end-of-lifed, some of them hacked. So there's got to be a way to very quickly and easily deactivate these IoT devices and take them out of the network quickly and easily. As well as once they're no longer in use, you can delete them from the system. So that's kind of what we did with our IoT registry. And we are continuing to do our development with this. And so some of the questions that we have are, where do we go with this? Because if CIRA says, hey, we're going to have this registry and it's going to be for Canada only, does this mean other CCTLDs do the same? So should every CCTLD operate their own IoT registry? How can we have more open source code that supports the Danish DNSSEC validation on mutual TLS connections? How should the inter-registry registration activity be trusted? So, you know, if the answer is every CCTLD operates their own registry, then does one registry talk to another? So is the trust in operating a CCTLD leverageable to operate an IoT registry? And then how do we differentiate the IoT registry from current hard-coded, locked-in major cloud provider solutions? So, you know, we've built enough of this registry. We've, you know, validated the standard. We've taken it a step further and actually use it in a real-life medtech platform. However, going forward, here are some of the questions that we need the broader community to answer or debate in order for us, well, not just us to move forward, not from so much a technical perspective, but just an adoption perspective. That's it. I think I'm here to answer some questions.
Thank you, Natasha. A very good presentation. We have some questions already in the Q&A session. The first one is from Elliot Lear from Cisco. He says, Natasha, great presentation. Interested in the specific middleware challenges you ran into at the SSL level. They also ran into some as well as relating to EST and CSR attributes.
So one of the challenges we have, you know, so there were the practicalities in that we had a timeline and we had to build enough to get to work. But at the same time, you know, part of the middleware challenge is that this is not part of the OpenSSL standard. So we had to use a Golang as a wrapper just to get this working and to set up that bidirectional TLS connection. It is, you know, it is a short-term solution in order to get this registry working. However, long-term, GSMA is working with some of the OpenSSL groups. But you know, we'd be happy to take this offline. It's a pretty in-depth discussion, so we'll be happy to take this offline and discuss it.
Okay. The next one is from Karsten Schaeffner, All Things Internet and Internet of Things. He asks, I might not have fully have understood the concept of moving IoT services from one provider to the other, which is in your slide 5. As it appears predominantly, it currently is one distinct service per different provider, other than with domains where the service can easily transfer from one registrar to the other.
So in an enterprise situation or in industry in general, once some technology has been adopted, there's always the push for cost savings. And so the challenge that organizations have is, hey, we've tried this technology, we've used it, but now we need to have a cost savings. And so today, with our IoT devices, the challenge that we have is that they're in walled gardens. So if you if you have your IoT device and you use some of the big cloud providers today, you're pretty much locked in as a vendor and as a customer. You have no other options. But in the future, for it to scale, it's kind of like when the internet was hard-coded, we couldn't scale. We're now at millions and billions of domains because of this transferability and that flexibility. So in order for IoT and smart cities or any of these things to happen and scale, it's really having this flexibility. So if I'm a parking meter, for example, and I'm leveraging ParkoServe, which is a cloud provider, and as an IT department, we have to reduce our costs. But hey, look, CarParkServe is giving us this fabulous deal for our cloud services. CarParkServe also provides cloud services for parking meters. And so it's the parking meters that are generic and have that interoperability. And so you will be able to transfer between these parties. So we don't have full transfer working today because we just started with the MedTech platform. However, we have partner transfer working in the sense that in order to transfer, you have to deactivate, and then you have to change your port and your URL or FQDN, and then reactivate it again. So it's not a complex thing to do. At the end of the day, you're just changing endpoints. What is more complex to do, which is the outside of the scope of our registry, it's really with the cloud providers being interoperable from that context, and as well as from the IoT devices.
We have 3 more questions and we have 3 minutes. So I will stop the Q&A line. The next one is from Florian Strebelt. He says, great work. I wonder what the threat vectors are. Would it be possible, example, to disable all IoT devices on a country level in case of conflicts between states, example, sanctions?
I would say the threat vector is, very similar to shutting down of all the domains in a country. So with this registry, you'd be able to fairly quickly to deactivate these IoT devices. So what by deactivation is you are shutting down that secure TLS connection, right? So there is a mechanism, there's a theoretical mechanism to do that.
The next one is from David Schweizer, NetDev. How does technology impact second-hand sold devices? Can devices be reactivated without the registry, that is, after the vendor stops offering services for it?
So that is a good question. We it's it's a level of detail that we have to work all the way through. But from our thinking or where our implementation today, where we're at is that you can the IoT device will have this eSIM that has a public-private key on it, right? And so it's through passing of this public-private key to our system and what we call the registry payload. You're able to really say, hey, this device is who they say they are. So when you deactivate it and delete it from the registry, that public-private key is no longer there, right? Like that is what we call the hardware router trust. So from a theoretical perspective, if something is end-of-life or it goes into the recycling market, it would most likely have to be reactivated again. However, we'd have to actually test this out for that use case. But based on what we have today, we believe you should be able to do that.
And the final question, Swati Vetrivel from TU Delft. Again, kudos to your presentation from her. Can you touch upon the feasibility of large-scale adoption of this model in consumer IoT devices, since they tend to be more plug, play, and forget?
Sandosh, sorry for interrupting, but I would really like to present the few results of the survey we have, but I would suggest that you take that to spatial chat afterwards, to the coffee break area to discuss that further, because I believe all our speakers are actually planning to be there.
Look forward to the discussion. Thank you for having me.
Thank you, Natasha.
Thanks, Natasha. Okay, if you see nothing, that's good. So, all right, a few of you might remember that slide from the last meeting, since, let's face it, the IoT working group isn't the biggest party amongst the mailing lists, and since we couldn't meet and mingle at RIPE meetings, etc., the idea was to send out a survey to find out what we as chairs should do with the working group. So that's what we did, and basically kicked off the new year with it. The survey got 16 responses, 11 of which came from mailing list subscribers, 2 of which have never attended a physical RIPE meeting, unfortunately. Looking at 16 respondents, I'm afraid that's about the full extent to which any quantitative analysis makes any sense. That said, you guys are old. Just kidding, and I would really like to hear you laugh now. One of the first questions was what people view as the Internet of Things, and to be honest, it was a bit expected, diverse. So for some, it's anything with an IP address, focusing on internet connectivity. For others, it's mostly about the lack of classical interfaces, clearly putting the emphasis on a device's function without human interaction or with unusual human interaction. Some explicitly point out the things talking to things part over some kind of an API in any network, basically. And for a few, it's just the security threat with unreliable maintenance. So there's that. I might be wrong here, but maybe we should discuss after all whether we as part of RIPE should try to define this for ourselves and where we maybe put the emphasis on. Moreover, we also asked the people that are not subscribed to the mailing list why that is. It turns out 80% didn't even know it exists, which is why I'm going to put the URL to subscribe on every slide now. Also, there seemed to be some insecurity about how this whole working group thing works in the first place, both amongst new members as well as members to be. So explaining that might be something I'd like to tackle next. So while the non-subscribers seemed quite happy with what we do, there was indeed some feedback on what we should do more or less of, what we should start doing, keep doing, or stop doing. And one thing I'd like to mention first, or rather quote, is I think that despite some extensive efforts to set the charter, it still isn't exactly clear why the working group exists, other than a general feeling of why we should be doing something. Considering the reasons we sent out that survey, I think that one takes the biscuit, because looking at other responses, I have to say there's quite some bandwidth between wanting us to be a source of credible technical information on an accessible level and being a source of advice on how to regulate IoT as an industrial sector. So if you're not sure what to think about for the next 2 minutes, make it that and let us know about your thoughts, please. So what else was there? There was a general wish for more communication, feedback, and discussion. And let me just say here, I feel you. And I hope that whatever we do next, that's going to be a natural consequence. Then also collaboration was a thing I read on and in between the lines a few times, implicitly pointing towards other working groups within and outside of RIPE. As you can see, security is still very present, as that's pretty much the one topic we talk about all the time. I guess I need to mention that our respondents seem to miss the focus on network operators and also would like to see recommendations specifically for ISPs. And we should also try to include operators that operate large-scale IoT networks. And as an answer to that question that was added within the response, I happen to know they exist at RIPE, and I'm already working on it. That said, if anybody feels called upon here, really, please just say hi sometime. Because that ties in quite well with what we apparently should do less of, which is home assistant stuff. Although I've also seen kind of opposing opinions on that one. So this is just a pretty small excerpt of the responses for now, because I want to lose 2 sentences on how it was to look at the spreadsheet for quite some time. To be honest, I was surprised to look at a huge variety of backgrounds, both professionally and personally, and also a huge variety of interests, and was actually tempted to stick little pins with red thread into my screen to connect the cells. And that was both pretty cool, but also reminded me again why we really need those physical meetings. And maybe for now, as cheesy as it may sound, also some kind of "Hi, my name is" introductory posts for new members on the mailing list. That would be nice. To conclude, as the major next step, it would be really nice to have some sense of purpose, and also some kind of coordinated roadmap for the next meeting. And with that, I'm looking forward to your feedback now. Anyone in the queue, maybe? Oh, there you go. Sandosh, are you operating the audio queue?
Yeah, I'm operating the audio queue. Just a minute. There were people asking to send video, but I don't know. So there is a question from Peter Koch. The survey is still open. Are you considering future responses?
Absolutely.
Okay. So just a minute. I will grant audio to Daniel Karenberg.
Hi. couple of things. Thanks for the survey, and thanks for asking the question. I think, if I remember it correctly, in the genesis of this working group, one real big concern was that we, as a group of sort of classical ISPs, saw that the operation of sort of IoT things was using our services. Basically, lots of IoT stuff uses the internet. And we wanted to give an interface for the people sort of using us and using the services of the ISPs to talk to us and give us their requirements and basically talk operational stuff, so that we know that there would be less surprises and better result for everyone. And I think that should be at least part of the charter. One thing that I heard you say, oh, there should be an introduction on what the working group does. Well, that's the charter. So I think I would suggest that the group really works on finalizing the charter, and then it will be clear for everyone what the group's proposing to do. And when you have the charter, you can also look at the work plan, stuff that roadmap, whatever you call it. So I think work on the charter and put in the interface between classical ISPs and IoT deployments. Thank you.
We have two
Thanks,
more.
Daniel.
So I think we can go into the coffee break, isn't it, Constance? And let them.
Yes, the coffee break area. I don't know what the policy these days is for running late.
I will let Elliot and Marco to ask, and then we will go to the coffee break.
Hi, everybody. Good afternoon. Good morning to those in America. I just want to thank Constance and Sandosh for their work here. And thank you, Constance, for conducting the survey. I want to make one general point, and I'll use the slide that's on the screen to make it, where it says less of home assistant security stuff. The reason that you saw a VCOP come out along the lines of home security was that we saw a role for service providers to play here. That is to say, there's a consumer aspect. The consumers need to be represented. Consumers need guidance, help, easy interfaces to make simple decisions about the devices that are on their network. And the ISP is a natural player in that space because we have the relationships with consumers already. And so that leads to this charter discussion that Daniel mentioned. It seems to me that the work that needs to be done in this space needs to relate directly to what the right community can have influence over. And that is to say primarily the role of service providers, and indirectly the role of consumer gear, the role of IoT gear, even the role of industrial. And by way of example, right, we just saw a huge break-in in the United States involving a pipeline that took down good portions of the southern economy, at least for brief moments, in the United States. And that was due to a failure on the part of how the pipeline how remote access was being used by the pipeline management. And so one question that I think we can ask is, what is the role of the service provider in facilitating and in helping industrial users in terms of, in as much as they are at all connected to the internet, and they had to be connected to the internet in the last year due to COVID, because people had to continue to work from home, and they continue to work from home, but there were people needed help finding best practices, some didn't, and we had failures like this. So as we go into this discussion about the charter, we should be thinking about questions that service providers can address. Anyway, thanks for the time.
Thanks, Elliot. So again, we're going to take this into the coffee break area. Thanks to Saeed and Natasha for their interesting presentations. Please rate the presentations, everyone who's still here and participating. Right, and have a nice rest of the evening. evening, the rest of the meeting. Bye-bye.
Thank you, Constance. Bye.
I hope they can play the song again.
Hello there.
Hi. Hello, work group.
Hi, everyone. So we still have a couple of minutes before the official start of the meeting. We can spend that time figuring out how to show the slides. Good, works. Right, it's 30 minutes past. Hello everyone again, and welcome to the routing working group. Myself is Ignas Bagdonas and my fellow colleagues, co-chairs, Job and Paul. So another virtual RIPE meeting and another virtual routing working group in that meeting. Let's see what we have here for the administrative part. Housekeeping is exactly the same as it is usual for the virtual meetings. Please mind the microphone etiquette. The chat in particular is used only for talks between the participants and not for asking the questions. Please use the question tool for that, and we will read that out to the presenter. The minutes for the past meeting have been posted. There have been no comments on them. If you are curious and did not participate last time, I want to take a look there. And if you have something to comment on, please do before the end of the meeting. Afterwards, they will be finalized and archived. So for the agenda part, we have 4 presentations this time. We have a quite packed agenda, therefore we will move straight into that part. Job, stage is yours.
Thank you. I would like to invite Emil to connect to the system and launch their presentation to give us an update on RIPE's Routing Information Service. Emil, take it away.
Hi. I hope I'm not muted, and give me a couple of seconds to share the preloaded slides.
We can hear you clear.
Perfect. Yes, share slides. There we go. And we have slides, right? Okay. So I'm Emil Aben. I work at RIPE NCC, and I'm going to do an update on our routing information system, which we typically do in the routing working group. For those of you who don't know RIS, it's a routing information service. Our goal is to provide insights into the BGP routing system, and we've been doing that since 1999. We collect data on the control plane. And there's some numbers there, 1,300 BGP sessions. It's an important data source. It's for a lot of NetOps tools. We have, of course, our own RIPEstat, but also external tools like BGP.hditnet and BGP Alerter that's maintained by Massimo at the NTT currently. So these are all things that sort of like use this to shed light on what's actually going on in the BGP routing system outside of your own networks. What we do is we create open data. We produce MRT files that have updates and periodic dumps of the state of the routing tables that we collect. And we also have a live stream, like we call it RIS Live, for instance, to like BGP Alerter is So one thing I want to bring to your attention is that we're thinking about our role in the sort of the internet ecosystem, and I think it's a pretty important role. Of course, like I like the project. I think public route collection is important for the health of the internet. So actually, you can see outside of your network what's going on, and actually there are of course other big route collector projects out there. And that's useful for having a diversity of governance of these projects, diversity in technology. So if one goes down, the others are left. It's robust against failures, outages, funding, security issue, just name them. And to that extent, we've started collaborating with other route collector projects more, and specifically Route Views. We do tech transfer, talk about issues we're dealing with. And then another thing that I think is pretty important is that we are trying to synchronize on types of metadata that we are collecting. So we are collecting a vast lake of data, and you want insight from that vast lake, and sometimes that's a bit hard. So having some pointers there into what data we have, what peers we have, what data we are collecting from them, what's special about peers, and stuff like that. We're trying to document that. There is a living document. I'd love to get some more feedback on that, because I think it will make the project better. So as the operational status, it's more of the usual. We have more peers, more data. Actually, the number of peers didn't grow that much since 2020, but the amount of data we are collecting is actually quite significantly growing. And we have only one extra RRC. The RRCs are the route collectors we actually put, and mostly we put them at exchanges, but we also have a couple of ones that do BGP multi-hop, so it doesn't matter where the peers are for them. We had one multi-hop in Amsterdam, and now we have two. The first one was considered full to the extent that there was such a chunk of data that we had to produce all at the same time that it's better to have an extra one. We're doing things slightly different with that one. It's a virtual machine, and we are asking peers to provide some of the metadata that we're after. So the geographical location, because for the most of the multi-hops, we don't actually know where the physical router is, so we don't know where we are collecting geographically, and what feed type we're getting, is it full or not. And actually, we have one more route collector plant in Dubai, because if you see the picture here, you can actually see that the Middle East, we don't collect data from there. And we have an agreement with the host in Dubai to get peers from various countries across the region. So that would add to our diversity. So that's a pretty good development, I think. Well, of course, there's a little bit of a downside of these expansions, is that we've seen additional delays, and we've received some complaints about data delivery having too much of a delay. So we started measuring that. And for instance, for the last month, 30% of the data had a delay of over an hour or more. We can explain that by the more noise, bigger tables, more peers, but we would like to be more timely. So, of course, we're gonna improve the backends, but another way of providing more timely data is to not chunk up peers into RRC-based collections, but we'll still keep that going. But we also plan a prototype of per peer MRT files. So you'll have, in addition to the normal files, a lot more files that can be produced much quicker, especially if one or two peers are really causing delays in data we produce. And we've become a little more restrictive in accepting peers. So that's one thing that we're also doing different. We have a new role in the team, this the peering coordinator role. And what we used to do is we had passive inputs. We had a form, and we would just configure whatever was we got in. We're now discouraging multiple sessions. We've seen a lot of, not a lot, but very redundant tables being sent to us, and that just adds to delays and adds time to decreases time to insight. We encourage diversity in the feeds that we're getting. So if we have a feed from somewhere that we haven't collected from before, that's of course preferred. Or we will prefer that. And sometimes we're not asking for a full feed. We still have the context, so if at a later point a full feed would be useful, we can still change that, of course. One thing that is definitely different is that the peering coordinator now also actively goes out to seek out high value, like diverse peers. And as a first step, what we're doing is we're trying to get all the tier ones feeding data into RIS. And for the future, we're trying to find methods to systematically go for finding new high value peers. That's a topic I'm particularly interested in. So, but what we would like most of all is input from people who care about this project on what we should do next, how we should develop the project. So if you want to have a chat with not just me, but also the rest of the team, the peering coordinators, we have a room in Spatial Chat that will open up after this session, because we all want to hear the other presentations too. We're interested in feedback and use cases, and there's some topics there that we're particularly interested in. And with that, I hope I stayed within my 10 minutes, and I'm either open up for questions or hope to see you in the RIS Jam room after this.
You are perfectly on time, so there is time for some questions. I have one question myself. What is a tier 1 provider?
Yes, that's a good question. I basically, we use the list on Wikipedia because so if you change that list, we'll also go after these networks. Yes.
No other questions.
Okay, cool. Thanks, and hope to see everybody.
Thank you for your time and for your updates. So next up, we have Natalie Trenaman about RPKI, which is either really problematic keying infrastructure or some other abbreviation. Natalie, the floor is yours.
Hello. I'm visible and I am sharing my slide. That's not my slides. Try again. There I am. That's better. Hi all, my name is Natalie Trenaman and I'm the Routing Security Program Manager at RIPE NCC. In this presentation, I will give you an update on what we've been working on to improve RPKI and what is on our roadmap. I have 10 minutes and a lot of things to share. And as you might know, RPKI is booming and RIPE NCC operates one of the 5 trust anchors for RPKI. This means that we really have to step up our game to ensure that the certificate authority that we run, that it's stable, resilient, and of course secure. And in the last year, we have made a lot of progress in different areas, and we call the overall project the RPKI Resiliency Project. It consists of the following areas. You can see that on the slide. And in my presentation, I will go over each area in a little bit of detail. So starting off, As RIPE NCC, we receive more and more requests for compliance. This has to do that larger companies, global companies, start using RPKI, and they want to have answers to certain questions. That's why we started last year to develop an RPKI audit framework, because we looked at all the different audit frameworks out there, and none of them was really applicable or a right fit for RPKI. So we teamed up with a company called British Standards Institution, who develops standards, as they do, and worked together to find the best fit for an RPKI audit framework. So we have chosen to go for a SOC 2 Type 2 audit framework, because that allows tailoring to a certain extent. And we tailored that to match the key elements of RPKI. And it allows us also, and this was very important to us, to publish a SOC 3 report with the findings of such an audit. By doing this audit framework, by developing this, that also allows us to share that framework with other parties that want to have an extensive audit done for their RPKI framework, for their RPKI infrastructure and procedures, etc., etc. Now we're in the phase that we have finished the audit framework and that BSI performed a gap analysis. So basically, they identified 179 controls of things we should do. And that's a long list. And at the moment, they identified that we're not complying to 49 of those controls. That sounds kind of dramatic, but when we went internally over the list, we see that around for 50%, we have the controls in place. We just have to provide them. So think of log files, stuff like that. So around, I would say, 25 are actually missing, and that means that we have to, work on those. And that's what we're going to do the rest of the year. Now the thing is with SOC 2 Type 2, which is interesting, is first you have to have all the controls in place, so all the 179. Then you have to wait for 6 months before you can have the actual audit carried out. I never heard of that, but apparently that's normal. So that gives me also the time to find a third party, because of course we're not going to have BSI perform the actual audit. So that has to be another party, of course. Moving on. Another assessment that we needed was to know how far we comply with RPKI in relation to and crypto in regards to the RFCs. So over the years, a lot of RPKI-related RFCs were published, and some relate to the RPKI core, some to the publication servers. So did we interpret it over the last decade all the RFCs correctly? Good question. So we asked Radically Open Security to perform that assessment. That was done last August and September. They gave us the report in October. Then we started working. There were 35 findings of where we either did not implement the RFC to the letter, or we worked with a draft before it was an RFC. So anyway, 35 findings resulted in 35 actions, and we decided to be transparent about this. So we published 2 documents on a new part of the website for transparency. That's the original ROS report and the report that we wrote as a response to that report from Radically Open Security. So if you're interested in that, you can find it. Let me know what you think. Then an entirely different beast is the certification practice statement. When you run a certificate authority, it's mandatory to have such a certification practice statement. It must be visible on your website and it must be accurate. Now, last year we started to completely rewrite the CPS because it hadn't been updated in a decade. So it was high time that we did a complete rewrite of that. It's a long document and it's very detailed and very procedural. So it took a lot of time to completely rewrite it following an RFC. because there's an RFC for that, obviously. So we had it reviewed. What we wrote was reviewed by a PNIC, and then we published it in January as RIPE 751. Quite happy that was done. But of course, we're still working very actively in updating RPKI. There's still RFCs being published. So we plan to review the CPS every 2 years. Next time, I will ask the routing working group to get involved in the review, because I think it is a good practice to do this in a more transparent way and ask different eyes to look at it. So be prepared. In 2 years' time, I will come to the mailing list and say, hey, we plan to update the CPS. These are our proposed changes. Would you care to review this? And I hope the working group will help us with that. Yeah, then a fun fact. Exactly today, 2 years ago, we enabled RPKI, route origin validation, on the RIPE meeting network. And as you may know, last month, we, as AS3333, started dropping RPKI invalid BGP routes. The main reason we wanted to do this is because we want to eat our own dog food / haute cuisine. We sought advice on the routing working group mailing list, and we were very happy with the support you expressed there. So first and foremost, a big thank you for your support. Next, we checked who would be impacted by dropping these routes. And we reached out to 215 organizations associated with these 597 routes. Quite a big undertaking, and a big thank you for the registration services team who did all that work. I was very curious to hear what would come back out of that, if we would get a lot of concerned members or angry emails. Nothing of all that. We had a handful of questions from members, mostly asking us how to create ROAS. So yeah, we did a lot of answering questions there and helping people out. I still have some calls scheduled after the RIPE meeting to talk people through this process. It's quite simple when you see it, but some people really would appreciate a little bit of help. Another thing we decided was not to build a backdoor to my.ripe.net. So if people had a typo, for example, in their ROA with the wrong AS number or something, and we would drop their route, effectively that means that they can't access my.ripe.net anymore, or www.ripe.net. The thing is, we decided not to build a backdoor because that inflicts all kinds of other mess. We would not know who we allow entry through that backdoor. So, but we had to do something, of course. So we added a warning for LARs and end users, so PI holders, that are about to lock themselves out of the LAR portal. And so, for example, if they're about to make a typo, and we match with what we see in BGP, and we think, ooh, this might cause problems, they get a warning. And it's quite a clear warning, we believe. People actually have to type something there to confirm that they understand what happened. Credits where credits are due. I want to thank the ops team here, because the registrations team emailed everybody, but in the end, the ops team adjusted the configuration. And Menno and Marco in particular, who did the work on the technical side. Then another bit of news, different kind of news. So in RPKI, there are two protocols that you can use to fetch the information from the repository, RDP and rsync. In April, we received a report from a user that there was a data atomicity issue that resulted in a non-repeatable read. My colleague Thies sent an extensive email to the routing working group and another one around 45 minutes ago, explaining the issue and what we are going to do to tackle this. So we worked really hard the last few weeks to fix this issue. We made it our #1 priority, obviously. But fixing this wasn't trivial. We had to do to improve the publication process in the RPKI core so that we can update the whole tree in one go. And we also have implemented as a second solution CrillSync, which is software from NLNet Labs that generates rsync files from RDP. We have tested this internally. We're positive that these approaches solve the problem. So we have now basically provided a public test bed, and we would really like your help to test things before we go to production. So the team sent an email to the working group list. Please reach out to the team if you want to help us with testing. It would really help us. Another project we've been busy with, and you heard quite a lot about that this week already, is the redundancy of the publication service. At the moment, the rsync repository is completely hosted in-house, and RDP is in the AWS cloud. This has been the case already for the last 4 years, at least, maybe 5. The goal of this whole exercise is to have a very high uptime, so availability is key here, because this is simply critical infrastructure. I mean, this is the repositories is what people consume, so it has to be available. The first step that we needed to take to do anything was to make sure that we build software that can take off publication on multiple places, whether that be in on cloud or in-house or whatever. But we want to be able to have multiple publication servers that can be accessible and have the same data at the same time. That's not easy. So we worked quite hard on that in the last few months as well. This is now done. We still have to decide on the fallback scenario. If that would be in-house or in a second cloud provider. Felipe wrote a labs article. Also in the services working group, there were some presentations. We really need your feedback here. So please reach out. Tell us what you think. I'm very curious to hear. Now, in the last RIPE meeting, I announced that we're going to deprecate the RIPE NCC RPKI validator. And since then, I tried to reach out to all known users where I could possibly find an email address and ask them to migrate away and inform them about our plans. Now we see a trend line going down, but it's not going that fast, not as fast as I hoped. So we still see around 300 active clients. Please help us spread the word, because as somebody said, friends don't let friends run sunsetted, deprecated software. So please spread the word. If you know these people, tell them. On our website, we have alternatives. You don't have to stick with RIPE NCC RPKI validator. So we are stopping on the 1st of July. That's a hard date. Dramatic pause. Almost done. Coming up soon, we will have, by popular demand, the RPKI roadmap on the website. So what are our priorities? What are we working on? What can you expect? Also, by popular demand, a status page. Now, this will not be a status page just for RPKI. It will also include other services. So bear with us, but it is work in progress. And of course, I want to, also for compliance, but also for reporting back, not only to this working group, but to all users, I want to publish quarterly RPKI health and progress reports. I think it's important to tell you where we are and not just every 6 months here in the routing working group. Plus, we're working on more streamlined way to incorporate community feedback. Because now I get a lot of emails to myself or on IRC or wherever. Natalie, can you do X, Y, Z? and it's not very transparent. It's not very clear which questions we get, which feedback we should do first, look at. So we're looking more in a way to have that streamlined and transparent. All right, 1 more minute. The RPKI roadmap. So this is how the roadmap looks for me, for the team, and our plans basically. So in the first line, you see the operational and procedure and operational compliance. This is the BSI stuff that I was talking about. Closing the gaps, select a third-party audit that party that can do that, and then 6 months later, after we close the gaps, the audit execution. And then you will see that this is an interval thing. So we just did the RFC and security compliance. We implemented the findings from the ROS report. 2nd week of June, we start a pen test. Then we will implement the findings. Then hopefully before the end of the year, do a red team test. Then again implement those findings, and then in June again next year another pen test. So it's a continuous cycle of security assessments, because I think we need the habit of that and get used to that. Then RPKI route origin validation. It was on my January wish list. It's done now. It works. Happy news. Done. On the technical infrastructure side, the rsync fixes, as you can see, it's almost done. I'm quite happy with that. Then for the cloud deployment stuff, multiple publication in test. So that's where we are now. Hopefully into production soon, because then we can continue with the rest, looking at multiple availability zones, multiple regions, fallback in-house, second cloud provider, everything there. Hopefully before the end of this year. Something else that comes back every few years, of course, is the new HSM. So we've got hardware that we need to replace, and this is scheduled basically for most of Q2. So starting soon, and then we already did quite some pre-work for that, but we still have to continue that. It got halted a little bit because we had the full team on the rsync problem solving. Right, that's it. I'm looking forward to any questions.
There are questions. Let me thank you for this update. This was highly informative. And I would like to join your call to decommission and turn off RIPE validators. RIPE validators can be crashed remotely and be used in a botnet orchestration. So people turn off these pieces of software. They're dangerous. Paul, could you guide us through 4 questions in the queue? And 4 questions also means that the queue has now been cut to allow time for the other speakers. Paul, swinging the mic towards you.
First question from a certain Mr. Erik Bijs. Hi, Natalie. Did the RIPE NCC RPKI team set up a RPKI client testbed towards the rsync testbed? And what was the result of that? And if not, since the problems are with the RPKI client, why isn't it tested? I would assume that an RPKI validator client testbed with the various software would be helpful.
And I completely agree. And of course, that's an obvious yes. To your first question, did the RIPE NCC RPKI team set up an RPKI client testbed towards the rsync testbed? So the answer is yes. Very recently. So we don't have the data, much data yet to share, because it's quite recent. But we have RPKI client running there as a test. I hope that answers your question.
Next question from Benno Overeinder at NLNet Labs. Thanks for sharing the roadmap plans. Are there also plans for a publication server for RIPE members to publish ROAS, a service like APNIC is offering?
Yep, I know what you mean. So that's publication as a service, as you will, because that's what we see with the delegated repositories, that operators find it quite hard because it is critical infrastructure. They ask basically other parties to since they are going so resilient, can I piggyback on that? No, it was on our roadmap. Then it dropped off the roadmap because we had to change the priorities because we first have to be completely resilient ourselves. So it got postponed, and hopefully we can look at that again next year.
Third question, AJ Wolski. Hi, Natalie. Now that RPKI is a critical infrastructure not only for LIRs, how can non-members report and ask questions regarding problems or inconsistencies with Anchor or distribution?
Good question. Thanks, AJ. Well, rpki@ripe.net is not just for members. Anybody can use that email address. It goes to the team and to me. So rpki@ripe.net is where you can go with that. I hope that helps.
And the final question from Rudiger Volk. Is there a publication real-time of the routes rejected by AS3333, or is it planned?
Ooh, that's a nice one. Thanks, Rudiger. No, at the moment we don't publish that. I see your point for real time, because that changes, of course. Yeah, I'll take that back to the ops team, see if we can do that, if that's even possible, and how and where. Thanks. Anything else?
No more questions.
Thank you so much, Natalie.
Thank you.
Next up, we have Massimo Candela from NTT Limited, who will give an update on NTT's RPKI deployment and what the current state is. Massimo, the floor is yours. Massimo, we cannot hear you. Press more buttons.
Perfect. Can you hear me
yes.
now?
Perfect. Loud and clear. Thank you.
Thank you very much, Job. So, okay, my name is Massimo Candela. I work at NTT. This is going to be a quick update about our RPKI deployment, but mostly it is to introduce you to what we did in terms of automation and monitoring to ease our RPKI operations. And I hope this can also be helpful for you. You may be aware, NTT adopted RPKI, but also we are doing monitoring of BGP and RPKI. For doing this monitoring, we are using a tool called BGP Alerter, which is open source, and it was also cited in the presentation of Emil. Why we are doing this monitoring? Well, essentially because we want to be informed soon if we do any error. Let's say, in my opinion, the main, let's say, root cause for a lot of operational problems while dealing with RPKI are related to the fact that RPKI and BGP are supposed to work in sync, but they are two completely different planes, and so you have to put some effort in keeping those in sync. Just quick examples, you may create a ROA, and after you start announcing a prefix, but some RPKI repositories, they have a publication time that you have to consider, and maybe in the meanwhile, you're announcing something that is not valid. Or another example could be that you create this ROA, announce the correct prefix, and 6 months later, one of your colleagues starts announcing a more specific, and the prefix length conflicts with the max prefix length that you specified in the ROA, and again, you are announcing something invalid. So basically, you have to put some effort to keep everything under control between these two planes. And I see that two factors influence this. One is a lack of automation, which definitely increases the risk of committing or having incidents because you have to put human effort to keep everything under control while you could automate that. And a lack of monitoring can increase the impact of the incidents, like you don't get notified timely, maybe your customer will let you know that there is a problem. So we put a lot of effort, was one of our goals to do something about it, and we created a system, a centralized system where we do a lot of our operations about our prefixes. Which you can see here, the main user interface. Basically, we have a list of our prefixes, and there is a quick overview of their health status, if they are visible, if they are RPKI valid, if they are monitored. And we can click on one of these. We are able to edit various parameters. But now the only thing that we are interested in this presentation is the RPKI part. So what this panel allows is to basically manage the ROAS. So what you see at the bottom is what are currently the ROAS that they are affecting the selected prefix. You see that these have a status, which is in this case stage and stable. We will see what that means. But for now, focus only on the fact that there is a division of the screen. On the left, there is current status, and on the left and on the right, the future status. So the current status is essentially a normal RPKI validation done with public RPKI repositories. It tells you what the prefix is currently. The future status instead takes into account all the ROAS that they are in this list below, and these ROAS, they don't really exist yet on public repositories. So basically it can give you an idea of what it will be once you push this ROAS out. So essentially this is the core part of what we did is we envisioned this approach based on 4 stages, 4 statuses for the ROA. When you create one, it is marked immediately as stage, but this is not, I say create, but it's just an entry for now in our database. It's just something that we can only see. And what we do is we merge this with the public ROAS. So we merge public and stage ROAS, and we calculate the future status based on this merge. And if what is currently announced, or it's supposed to be announced, because we can also set that, is RPKI valid, only in that case, we basically are able to take all the entire ROAS that you saw in that list and commit all at once, basically as a single operation. Only in that moment, we reach the next status, the ROA are committed, which means that basically in that case, they can be sent to the public repositories or wherever you want. And what we do is that the ROAS, they will keep staying in this committed state as long as we are not able to see them from public repositories. So only in that case, we mark them as public, and we know that for now, BGP and RPKI are in sync, at least for now. So we start a monitoring about both BGP and RPKI. We will keep this monitoring forever, because of course we want to monitor not only that what we did at the RPKI is correct, but also that nobody in the future changes anything at the BGP level that conflicts with what we did in the RPKI one. But anyway, we have a 4th status, which is stable, that happens after 24 hours without incidents. And this one is mostly to basically wrap up the operation and consider it done for now, and for example, close tickets automatically. So now we implemented this, and this is the part I think more interesting for a wider audience. We implemented this by using mostly open source software, BGP Alerter, which you can find on GitHub, and RPKI client, which also you can find on GitHub. So most of the logic, it is implemented already in BGP Alerter. BGP Alerter, it is a software that does monitoring of both BGP and RPKI. When we released this, our main goal was to make it easy to use so that more people, more companies would start to monitor their operations. It has auto configuration. There is no installation required. It's basically a binary that you run if you want, and there is no data collection required. This is thanks to amazing services like the RIPE-REIS that you saw in the presentation of Emil, which is a clear example of a community effort that few other organizations except RIPE-NCC would have been able to make it happen. Now, it does monitor BGP. You get visibility, hijacked alerts, but we care only here about the RPKI. You will get notified if you're announcing RPKI invalid, prefix is not covered by ROA, or if there is a malfunction and your ROAS disappear, or of any diff, any edit that your ROAS or ROAS covering your prefix may be affected. Additionally, there is an option to stage and test ROAS before publishing them, so you can create fake ROAS, and there is documentation that you can find online on how to do that. And this is, you can embed it in whatever you would like, REST APIs, whatever, but this is also with chat, and this is an example in Slack. The first two messages are a diff that you can get if any of your prefixes change, or the last one is RPKI invalid alert, just as an example. So my presentation is over. Just a quick update. So we are working on also alerting for expiring draws. Thanks also to Job for the support provided by RPKI client. There is a new monitoring for downstream and upstream peers. So basically, you will get an alert if a new upstream downstream peer appears that was not supposed to be there. There is more work on improving ROA staging or creating a pull REST API, so you can basically, instead of doing pull for the alerts, and much more. It's going to be a big release. So my presentation is over, and time for the questions. And also I leave here my email and my Twitter account in case you want to contact me later.
Thank you so much for this update, Massimo.
Thank you for the...
Sorry, go ahead.
No.
I'm going to hand over the microphone to Paul for the questions.
Yeah, we've got a question from Mr. Randy Bush saying, Massimo, very cool. Are there graphs of the rates of errors or discrepancies?
I mean, okay, I get what you mean. If I can release numbers of, because at the moment we're using this system for internal operations, and I don't have at the moment numbers to give you like how many incidents happen, and it's something that for sure I will have to ask authorization to release. But no, there is no public graphs for now. I hope I answered the question.
I think so. Next question from Mike Booth, Liberty Global. Where does BGP Alerter get its RPKI data? Understand, is it RIS or any other sources?
So it gets it from wherever you want, essentially, because at the moment there is a concept of a VRP provider, which are some common like there is like the Cloudflare one, the RPKI client one of Job. There are various that they are public, so you can select any of that. But that means that you are basically delegating somebody else to provide you a VRP file. What you can also do is to do your own validation in-house and feed the VRP file that you would like. So you have both options for the RPKI data.
Thanks. No more questions.
Perfect. Thank you very much.
Thank you so much, Massimo. That brings us to our next presentation. Alexander Zubkov will share about routing loops. Alexander, are you ready?
Yes, I just need to open the presentation.
I can hear you loud and clear.
Great. Okay, hello everybody. Today I want to talk about routing loops. And as you may know, routing loop is a situation when some packet routed infinitely or almost infinitely in a loop among some routers. And we can have such situation during dynamic routing protocols convergence. And for BGP internet, it can take minutes sometimes. And another option, it can be caused by stack routes in the dynamic routing protocols, also it can be caused by configuration errors, and such loops are persistent and until the configuration error is fixed. And the easiest way, and I think the most popular one to get such a situation, is with unused IP space or badly routed net pools. For example, if some provider assigns and routes some space to its client, and the client uses only part of that space, and so the remaining addresses routed back by default route, for example, back to the provider. So we get a loop here. And this situation is easy to fix on the client side if you null route all the addresses you receive from the provider. So that any unused addresses are dropped and not looped. Also, if a provider can implement some anti-spoof policy on the client's interface, in that case, it can break the routing loop from misconfigured client also. So BCP38 is helpful here. So what's the problem with loops? It may be obvious, but for example, my former internet provider called it cosmetic issue. So the main and biggest problem is possibility of high link utilization. For example, if we have a packet with high TTL that reaches a loop with 2 hops, we have 100 times amplification. It's easy to understand. And so such link can be a target of DDoS attack, or if it is linked to your provider, you can get increased bills because of that. And there are also less rare usages. For example, some very bad network loops can be used as DDoS means to other networks, or some guys described using routing loops for inferring the ability of spoofing from your network. Here I picked some articles describing such problems. For example, I put a quotation here. Guys found some infinite loops in the internet, and some of them generated replies for 6 days. I also made a simple setup of 3 servers and 2 switches to test the problems caused by loop. The loop is between switches, and here are the results. I highlighted yellow 2 lines with the same flood rate. The first is when the flood is directed to the server, and the second is the flood directed to the loop. And as you can see, in the first situation, the server wasn't affected at all. And when I flood the loop with slightly more than 400 megabits, I saturated 40 gig channel, and I got 5 times slowdown. And the interesting result is when it's green. When I tried to saturate the loop with small packets, and I got no slowdown. And I think it's because how queue is organized on switches, maybe some fast scheduling among ports or something like that. But anyway, we have problems with large packets, and if you have, for example, server or router, they had other bottlenecks than switches, and so they may be affected too, and also they may be affected more by large packets. At Curator Labs, we have a project called Curator Radar. You can register there. We collect different problems with the BGP or internet routing there. You can register and see what's happening in your autonomous system. They provided me with historical data over these years of the loops observed in our system. And I see a downward trend here. I hope this is not the migration to IPv6. Here are around 22 million loops. But I made my own research also for this presentation. I scanned the internet, and I've got 28 million unique replies, and this is around 1% of all active IPv4 space. But there are more loops because not all routers always replies, and there are many lost replies. And 1% is not so much, but these IP addresses located in 25,000 autonomous systems, which is 35% of all active space. So every third IS contains a loop destination. And the loops can be found also in autonomous systems of guys who I think should take the biggest care about connectivity and reachability, like CDN providers or DDoS mitigation systems. And not small, but big names are there too. And the fun fact is that I sent 4 probes for each IP, but in reply for each unique IP, I've got more than 4 replies on average. There are some amplificators there, and in some cases I have got more than 100,000 replies for one IP. I also tried to count unique loops. It turned out to be a hard problem, but I estimated that at least there are hundreds of thousands of them. And there are more than 500,000 of road IPs involved in those loops, that those are located in 20,000 autonomous systems. I found loops of lengths from 1 to 34 hops, and 2 hops is the most popular, obvious. And there are at least half of such loops. And there are loops that span 7 autonomous systems or 8 countries, for example. And the longest loop in the terms of time I found is up to 18 seconds. Here are statistics of loop destination by country. The United States is absolute leader here with more than 6 million loop destinations. And here are statistics in Europe only. Germany and Russia are leaders here. Here you can see statistics by autonomous system. The 2 leaders here is some national internet backbone in India, and the second is Lumen. But Lumen has several autonomous systems, and if you sum them up, they will have more than 600,000 of loop destinations. And I also want to show you some of interesting loops I found when looking at my data. For example, you can see there is a loop of 2 hops, but one router is too diligent and replies every time. Or, for example, you can see one route IP is answering, but if you look at round trip time, you can see a clear 2 hops pattern there. There are also loops when you have a loop of 70 hops, but only 2 hops replying. And these all are repeating patterns, of course. For example, here you can see, because it's large loop, there are loops of 34 hops, and I have an example of 34 hops loop which located in one network. Okay. And there are also some strange loops. I called this loop a flat loop because looks like packet is going back and forth in a row of routers. And that is not the weirdest one. I found such loop, for example. I completely don't know what's happening there. And I think someone enslaved as network administrator, and he hid such message to ask for help. So. And to ease the pain from previous slides, I wanted to show you some fun trace roads with artificially created names, but they all dead now with one exception. There was some trace road where you could see a Christmas tree with some rhymes, but you would not see Christmas tree now, but there are a loop now instead of it. So thank you very much for time, and hope you will not do loops in your network.
Thank you so much for this very informative presentation. The number of loops was much higher than I anticipated. So thank you for doing this investigation. I'm going to switch the microphone to Paul, as there are some questions.
Yes, Mr. Randy Bush. Nice study, so it is bad, but how to monitor and how to ameliorate?
For example, we monitor at Curator Radar those loops. If you mean in your autonomous system, as I can say, you can register and look at least what we can see for your autonomous system there. And what's ameliorate? I don't know that word. I'm sorry.
Ameliorate means how to prevent, or how can we solve the loops. Randy Bush likes to sometimes.
Loops caused by dynamic routing, I think it's hard to solve, but they are temporary, so we can live with them somehow. But other loops, as I can say, like null routing for unused IP space is very helpful. And BCP38, of course, also.
I see a question in the audio queue. I'm going to grant Rüdiger Volk the microphone.
Thank you. I wonder whether anybody is hearing me.
Yes.
We can hear you loud and clear.
Seems not to be the case. How do I get this done?
We can hear you, Rüdiger.
Quite fine.
Okay. We will try again.
Okay, let's see whether it works now.
It does.
Well, okay. First, for Randy's question, how to get knowledge. I certainly can recommend using the curator radar. The scanning results they are collecting is only available to people who in some way are authenticated as being in charge of the ASs. So the bad guys are not getting in easy ways the information where to attack. Looking at some of the stats that Alexander has provided, I suspect very much that at least for one of the German ASs, for which I only have been in charge I never was in charge of that. I very much suspect that a lot of the loops are due to use of default routes in the interdomain case. Quite obviously, when you use default routes, you are making the assumption that everything will be well defined, and quite obviously, in many cases, there are gaps which invite the loops. Alexander, do we have any indication of what the typical causes for the loops are, aside from the default case that I mentioned?
Unfortunately, I did not collect such statistics. I think maybe in one of the papers I had in references, they did something like that, but I do not know. But I do not see at least any other ways how to do it, like permanently.
It is challenging to figure this out. I see a few more short questions. Paul, do you want to go over them?
Yes, but we'll close the queue after this. First one from Jean Daniel at France IX. Have you got stats about internal, inside one AS, versus transversal, multiple AS involved loops?
No, I don't collect it, and also I think it's like not very correct statistics maybe, because on peer links you can see addresses from one AS, but actually it will be a loop of between different ASs. So, but I don't have such statistics.
Okay. Next question, short one from Dimitri. Can you share the Christmas tree AS number? you would like to test it next year.
You can see the nest name of the destination on my last slide, and you can verify the loop.
And last question from Lars Prehn. How do we know if it's really routing loops rather than just load balancings at complex infrastructure? I mean, trace routes are rather well known to sometimes report non-existent paths due to relying on various packets.
Not sure I clearly understand. If you see that packet traverses same route several times, it's clearly a loop. Maybe there are some weird situation when I saw some weird situation when one IP repeats several times in loop. For example, in this weird loop, you can see I highlighted some IPs appears in loop several times. I think maybe it's some sort of ECMP with including MAC address of incoming route, so it's like multiplied several ECMP routes. I saw also when some IP can repeat in loop several times in a row, then other IP goes. But all loops that I found, at least which I checked, and I verified it with trace route, I clearly saw that the pattern is repeating. I don't know, maybe there are some like other problems there, but I receive a TTL exceeded for big TTL, so I packet do not reach this destination, so I don't know what it can be else.
Thank you.
Thank you.
Thank you very much.
Alexander can be reached at green@curator.net. The email address is in the lower left of the slide deck. I'm mentioning this because in the chat I see that there's a lot of enthusiasm and theories.
It's on the first slide too, and we can talk in special chat also.
Fantastic. Alexander, thank you so much for your time. This brings us to the end of our routing working group session. I would like to thank all the participants and especially the presenters for their excellent work. And see you all in 6 months, hopefully, in the virtual, in the physical. We'll see what happens. Thank you for your time. Have a good day.
See you later.
Hi everyone, the last stretching session. So make sure you have the gallery view, then you can see me nicely big. And let's start immediately. Reach one arm all the way up, reach, 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 reach. And then bend gently to one side. Then let's go to the other side. Again, the other arm. Let's do this maybe 5 times each side. Let's do that. 3, 4, and 5. All right, now let's concentrate a little bit on our shoulder. All shoulders, then put the hands on your shoulders first. Then we go with our elbows all the way up and down, and up, and down, and up, and down. When we do it mindfully, we say, breathe in, going up, and we breathe out when we go down. For the last time, up, and down. Let's now, like the elbows want to kiss. So in front of you, and then open your chest. And again, make yourself nice little ball. Then we open up. 3 more times. And the last time. Very good. Let's start doing some circles. Let's do 5 circles forward. 1, 2, 3, 4, and 5. Let's go backwards. 1, 2, 3, 4, and 5. Okay, we are in the circle mode. Let's again activate our beautiful hips. Let's spread your legs and then do 5 circles each side. Doesn't matter which side you will choose first. 3, 2, 5. And then 1, 2, 3, 4, and 5. Very good. Now imagine 2 balls next to you. Then with the one hand you will touch the wall. Let's go from one side to the other side. Very good. Let's carry on. I will just turn this one. Whoa. Yes. And 2 more times each side. Very good. Now we want to do something about our neck. Let's spread our arms nicely wide, going with your fingers up, and we slowly go with one ear to one shoulder. And then see how you feel today. Maybe you are a little bit stiff on the one side. Maybe the other side is nicely flexible. But let's see first. A nice deep breathing. Maybe you can gently look up. And maybe gently also look down. And then slowly we will go with our chin to your chest. And we will move to the other side. Ooh, this side is much stiffer from my side. And then we look slowly, gently up. And slowly down. And you know, when you feel a little bit of pain, just say hello. And say, go away. Then slowly going to your chest. Let's shake a little bit arms. Let's activate a little bit our fingers. Still have to work. And the right dinner tonight. Very good. Let's do a few circles. Then we will move also the elbows. You know, each side. And then if it allows the place you are, do big circles. And then forward. Very good. Now, we have few minutes left. And maybe what is really nice, if you put the palms together, push the two palms. The shoulders fall down. Be careful that they are not moving up. Then start pointing the fingers down. Again, be careful that the shoulders are not up. Nicely down. Then we point the fingers again up and we move our arms all the way up. We will make ourselves really long. Put yourself on your toes and you are the longest in the world. Then bend your elbows and your hands will land on the upper back. All right, as last, I would love to finish with the dancing snake. I hear that's really favorite one. So again, put the palms together and start doing circles. And going from one side to the other side. And extend your arms. Or going more to your body. Going all the way up with small circles or big circles. We go all the way down. One more time up. And look at this. We finish. Thank you so much for joining me. And I hope to see you next time. Enjoy the live dinner. Bye-bye, everyone.
Good morning. We're here to talk about the database working group today. We have an exciting agenda coming up. First, I'd like to thank the RIPE NCC and the Secretariat for supporting us through this process. We really appreciate their support. But with that, let's get started. And Ed, you're up first.
Okay, hi everyone. Can everyone see my slides and hear me?
Yes.
Great, thank you. So hello everyone, my name is Ed Shrine. I'm a Senior Technical Analyst with the RIPE NCC, working in the database team, and this is the operational update. So there's 5 of us in the team, and this update is the result of their hard work. So thank you to my colleagues for that, for the last 6 months. Progress since the last RIPE meeting in October. Firstly, there was 2 WHOIS releases, 199 in December, and the most visible change was to require the -mnt suffix when creating a maintainer object, and this was discussed in the database working group. Second release was in April, and we fixed the managed flag on the Autonome object, meaning that you can see managed attributes, RIPE NCC managed attributes in search results for Autonome objects now. Previously, it was only seen for initnum and init6num objects. Now it's also the case for Autonome objects. There was a bunch of other under the hood changes, and all the details are in the release notes on the website. 2 WHOIS outages since October. One, we had a partial query outage for 8 minutes in March. It was to do with a rolling OS update. The servers weren't re-enabled properly after the update. The takeaway was to improve automation. We need to improve automation around server maintenance, because currently it's a manual process. Secondly, we had a database switchover in March. This is useful to do from time to time. So we practice in case of a failover, in case the primary server fails. And also we needed to do it for maintenance. So similar, doing package updates, making config changes, we need to do a switchover of the primary database. The good news is that it worked fine. Each time we switch over, it takes just a couple of seconds. But on one of the switchovers, we happened to catch an update that failed. And normally, WHOIS tries to will retry on a transient error with the database. But in this instance, the error that was thrown is a new one, so we have to take that one into account. But we aim not to have any user visible issues on switchover. It should be transparent. WHOIS features. So some statistics on recent changes and introduced features to WHOIS. Firstly, AbuseC validation. We're now at 102,000 addresses, up from about 90,000 at the last RIPE meeting, and we have about 3% invalid. And that's about the same percentage as before. The non-auth route cleanup. We're now deleting 10 to 20 route and route 6 objects a month from the non-auth database, and there's 59,000 remaining objects in there. NWI 8, to synchronize LIR portal users, non-billing users, to the default maintainer in the RIPE database. Now we're at 734 organizations. That's almost double where we were at RIPE 81. So this is good to see some uptake of this feature. NWI 9, we see over 150 distinct addresses connecting to our public NRTM now, and that's also up on the last RIPE meeting. Finally, we added country code data to the database, and this is the from the legal address of LAR organizations. That was covering all 24,000 LAR organizations in December, and since then we've been adding it for our new members as they're added to the database. In progress, there is the next phase where we're doing the same for end user organizations with PI space. Person objects. So there's a lot of personal data in the RIPE database, over 1.9 million. 1.7 million of those are referenced from initnum assignments. Normally, if a person is unreferenced, they are deleted, they're cleaned up automatically, but we can't do that as long as there are references. But the vast majority of the references are from INetNum assignments, and the top 10 LARs are responsible for just over 1 million of those. We did a cleanup last year to unlock person objects, which were previously unmaintained person objects, which were locked by the RIPE NCC, so they couldn't be updated. We assigned, we set 600,000 of those back to the allocation or assignment maintainer. Since then, we've seen that 13,000 of those have been deleted and 600 have been updated. And there are 13,000 locked persons that are remaining. We've done some analysis on those, but it's going to take a bit more time to go through those. So that's still a work in progress for the database team. And finally, I emailed the top 10 LARs referencing person objects from assignments in May this year. Ask them why are they adding person objects to the database. I think this is useful information both for the RIPE NCC, and we will share any, we will anonymize any feedback and share that with the Database Requirements Task Force, so they can to help them form recommendations around personal data in the RIPE database. Secondly, I reminded them of their obligations under the GDPR and the database terms and conditions to properly inform persons that they're being added and also to maintain them. And finally, I asked them to review unlocked person objects that we did last year to that we set to their maintainer. Data cleanups, we did 2 data cleanups around domain objects. Firstly, about 1,500 domain objects which did not have a required end server attribute. We deleted those. Mostly they were related to the ERX project from 2002, but there were some user maintained objects in there. So we got in touch with the maintainers of those objects in advance, and we announced it on the working group. Secondly, there was a trailing dot in some end server attributes. The convention since 2012 has been to remove the trailing dot, but existing data was not cleaned up at the time. And so now we've removed the trailing dot, so the end server attribute is consistent across the whole database. And that affected just over 500 domain objects. On the RIPE database website, we have a new website template, and this is now providing consistency across a lot of RIPE.net websites. This has already been done on RIPE Atlas and RIPEStat, but now it's the turn of the RIPE database and the portal, the LAR portal. So we think it's a cleaner interface. It affects the left-hand menu. There's a new header across the top of the page. We removed the footer altogether. There's a lot of detail in there. And we've also added an app switcher to make it easy to switch between RIPE.net websites. The main improvement, though, is to make it more mobile friendly. The pages implements responsive web design. And the major upcoming work here is to finish updating the right-hand side of the page, the database application space. There's some background reading. I've added some links to the RIPE Atlas redesign, which is done in November. That went out in November, and also for the portal and RIPE database, my colleague Theo has a labs article on that. Upcoming changes. Okay, so these are changes that we already plan to do in the next 6 months. We have an upcoming WHOIS release to align between the on-premise and cloud environments. We've noticed some environment differences that we need to reconcile. Firstly, now all timestamps will be reported in UTC. Previously or currently, some timestamps are reported in Central European Time. Thankfully, in the database itself, in the object data, the created and last modified is already in UTC, but in some places we report Central European Time. In addition to the timestamp in UTC, we also will consistently report the UTC time zone. We'll append a Z to the timestamp. And next, we'll be simplifying the HTTP redirect and rewrite rules. These rules have grown over the years, and we reckon this is now a good time to clean these up. And finally, we'll be deprecating some insecure TLS cipher algorithms that our proxy servers currently support, but that are not supported in the cloud environment. So we will align those, but of course we'll be announcing this. I plan to write a labs article with all the details, and there will be an announcement as usual on the new release to the working group. The unregistered route and Route 6 non-op cleanup, this was announced on the working group. There's a proposal for a cleanup. This issue was raised in January, that a /14 in Afrinic was deregistered, but there were route and Route 6 objects in the non-op database that were still referencing this prefix. A total of 23 of them. So the RIPE NCC, in coordination with Afrinic, deleted these route objects, but there are there's a bunch more in the in that database. So we propose a nightly cleanup job to take care of those also, and we consider available or unreserved prefixes in the delegated stats. We will use delegated stats across all the RARs to identify unregistered space. And currently using that metric, we can see 869 routes and 94 Route 6 objects in the non-op database fit that criteria. So the proposal is to run this every night, compare the prefixes with delegated stats, give a one week grace period in case of mistakes in the delegated stats, and then we will notify maintainers, and subsequently we'll delete those routes after 2 weeks, or we can exclude them given a good reason. GeoFeed, this is a new proposal for GeoFeed. It's being discussed extensively in the database working group already, and Massimo will be presenting on this after my update. But the idea is that a new single optional attribute will be added to INetNum and INet6num objects, superseding remarks that's already in use in a couple of hundred objects in the database. It's based on an IETF internet draft. It's already been defined as NWI13. There's a problem statement, a solution definition, and a technical impact analysis, but we're currently waiting for a legal review, as initial feedback from the database, from the legal department, was that GeoFeed data may qualify as personal data. And we want to improve the website more. Our next target is to improve the search interface. It's served us well. It hasn't changed much over the years, but we can see some improvements that can be made. Firstly, the search page, it acts like who is a command line wrapper. All flags are available all the time, and you need to understand how the flags work in order to use the page effectively. And in particular, filtering by type, by object type, and inverse lookup, it can be difficult to use, especially for new users. Also, out of region resources are not returned by default. So you'll get a placeholder if the resource is out of region. And also the full text search page is currently separate, so you need to know to go to that other page. That page is better for word searching, and you can match text much better using our full text search engine. So the implementation plan is to start work on this in the next quarter. We will solicit feedback from the community on ideas what can be improved, and also we will put pre-releases regularly into the release candidate environment for testing. Proposals. So these are proposals by the database team. We don't plan on working on these yet, but they have come up in the database working group. Firstly, who is tags? As noticed by Cynthia, there was an email at weirdness in DB files. We use DB tags. This is metadata for an RPSL object in the database. It was a beta feature that was released in 2013. Currently, there are 2 tags: a registry resource and user resource. But at some point in time, we stopped updating the tags, so not all resources are covered by these tags. They are included in some places, but not in other places. So they're included as comments in dump files, and you see them in the REST API responses, but you don't see them in queries, and we don't see use of these flags in the query logs either. So the question for the working group is whether whois tags should be deprecated. And the idea is if we have consensus on this, that we remove the query flags and the existing tags altogether. And we need to, the database team will publish an impact analysis on that in the working group. And secondly, white pages. This is a feature that was introduced in 2008 as a way to easily reference persons with a significant presence in the industry. And it also allows a reference to the person so they're not cleaned up automatically. but also subsequently, we have an exclusion list. The database team maintains an exclusion list for the cleanup job separately to white pages, and for a couple of reasons. Atlas anchor contacts is one. Some users are using it as domain registry contact details. We have reserve names, so there are primary keys in the database that are used in documentation. We use it for monitoring, and we use it internally for other reasons, like bug fixing. And finally, we've had some individual requests from users that they want to maintain their own data in the database. So the question again for the working group is, should white pages be deprecated? And if the white pages are deprecated, the idea is that we would instead move white pages persons to the cleanup job exclusion list instead, and that we would review the current exclusion process in collaboration with the working group. So that completes my operational update. Any questions?
There are some questions on the Q&A. First, Revstrom. I just want to once again reaffirm my support for emailing the top 10 LARs referencing person objects, and I hope to see more info on that, on how that develops.
Yeah, thanks for your feedback, Cynthia.
Reverend Sandco. In Remco's presentation in the Address Policy Working Group, he pointed out that there are about 30,000 objects with typos in the status attribute in the RIPE database. Various versions of assigned PA with different case on the characters. When will a plan to fix this be ready?
Well, the reason that that's happening is that the database is case insensitive, and we don't preserve case. We don't insist on having uppercase status values. But if this is an issue for the community, and if it's something we need to fix, then we can create a cleanup job for that and conduct an impact analysis.
From Randy Bush, who is working with NCC Legal on GeoFeed personal information implications? Need to talk.
Yeah, Randy, I can put you in touch or email legal@ripe.net directly. They are aware, and they are working on a response.
And finally, from Job Snijders, do the RARs use a detached signature to verify they retrieve the delegated stats from the RAR? I see a simple MD5 checksum exists, but perhaps a GPG signature on the MD5 checksum would improve assurances when delegated stats are to be used to remove RIPE non-auth objects.
Yeah, it's a reasonable question. We currently do use the MD5 checksums, and we do connect over HTTPS to download these delegated stats. But yeah, as pointed out, it is important. We do trust these files, so it's a good idea to check using a stat signature. That would improve it.
And from Daniel Karenberg, does stopping the white pages mean that DK58 will be deleted?
No, I hope not. There are only 4 pages. There are only 4 persons protected by this. But I think the issue is whether the community wants a community maintained list, or if they're happy to delegate this to the RIPE NCC. So that's the current situation. But yeah, the impact analysis, we should. The idea is that we should have a list of valid reasons, purposes for putting these persons in the database. The cleanup job is there for a reason, that we don't want unreferenced personal data in the database that doesn't have a purpose. And if we're to have an exclusion list or white pages, there should be purpose behind it.
Another comment from Cynthia. I would prefer the exclusion list over white pages, as it makes more sense to me. But regardless of what is used, I think we should have either, not both, white pages and exclusion list.
Yeah, I agree.
And finally, from Christian Bretterhofer, I see a lot of INET num and INET 6num objects with references to persons not from ISP, but from its customer.
Yes. So I believe this is the where persons are referenced from assignments. So the LAR would have created an assignment for an end user, for the customer, and there are a lot of persons referenced from assignments. And this is something that I'd like to find out more about, and this is why we're emailing the top 10 LARs to find out more about why they're doing this. I hope that answers the question.
Yep, that's the end of the question list.
Okay, thank you. I'll mute myself.
Okay, up next, thanks Ed, that was great. Up next is Massimo with GeoFeeds.
Can you hear me now? Perfect. Okay, so hello again. I'm Massimo Candela. I work in NTT. The presentation here is about our proposal of having GeoFeeds in the right database. And it is based on our draft at the IETF, which is done with Randy, Warren, and Russ. You will find more information there. So what is the problem? IP geolocation is important. If you have IPs wrongly geolocated, customers will complain because they cannot access some content in their region. They will complain with you, and you have now to fix it. And now the problem is there is no real defined approach how to fix it. So there is no central repo, no common strategy, no authoritative data. But what we have is a set of data sets, some produced by geolocation providers, others are forks of this data set. They are maintained directly by content providers. Basically, we have a heterogeneous set of sources, and what you basically can do is to email them and contact many organizations, hoping that at least one of them is the source of the error and the error can be fixed. So this is a list of, let's say, the most important geolocation providers at the moment, but there are many more, and this list does not include content providers, so you can understand that this type of interaction may be overhead if this happens often. What we are proposing is something really simple. It's based on 3 steps. Step number 1, you create a CSV file, which is a text file, where you add each line for a prefix or an IP that you want to geolocate. You put like prefix, comma, country, comma, region, comma, city, comma. So each line like this. This format, it already exists. It is described in RFC 8805. It is called GeoFeed. It is a really good format, and is already supported by basically all geolocation providers, including the one in the list before. So we are basing our effort on this format that is already used. So the next step is you publish it somewhere. But you just have to get a HTTPS URL, possibly HTTPS. You can also put it on GitHub. There are 2 examples. One is NTT, one is T-Mobile. And now you have a URL that points to that file. Of course, nobody else knows about this URL. And that's where it comes into play. That's step number 3. Basically, what you do is you go in the RIR portal, in this case, the right database. You find the INNAM that covers the prefixes that you want to geolocate, that you want to provide geolocation for. And basically, you add a remark that points to the file. So you write exactly this string, geofeed space URL. Now, what did you, this step basically allows you to make the file auto-discoverable, and also allows to create a chain that for basically easy ownership verification, let's call it like that. Also, multiple GeoFeed files, multiple INNAM can point to the same GeoFeed file. This is what also currently we are doing at NTT. So we have one file, you put your prefixes there, and you can point various INNAMs to that file. Now, this is an example of a GeoFeed file. You see that you can put country, region, city, but you can also just stop at country or don't put anything. So you can decide the details that you want to provide for each prefix. I'm going to skip this. This is where you can find the ISO country code in an easy to discover format. Here is how you add the remark in the RIPE database. Thanks, Job, for the screenshot. Basically, you go in your INNAM, you click it, you go in, there is a remark field, and then you add the string. When you save it, basically you obtain this. After you go, you do a WHOIS query, and you can see that there is remark geofeed, the file, blah, blah, blah. So now it is possible to discover this file automatically. So basically you have done, the only thing that you can do if you want like is to use a tool like this to do a test. You basically run it, runs on all platforms, you do -t prefix, and basically this will do the entire lookup. WHOIS gets the file, do the longest prefix match on the file and give you the answer. So you can check if you get back what you were supposed to get back. Now, why we opted for geofeed? Because in my opinion, it's an amazing format. It is extremely flexible. You can geolocate IP addresses or prefixes. You can put a /24 and a /16 in the same file because the longest prefix match will be used. You can also geolocate at whatever level, from nothing to just country to city. Also, you don't need to create an INNAM for each prefix that you want to geolocate, because basically you can take a parent INNAM, point to the file, and in the file you can create all the granularity that you would like inside the file. So basically you can keep working on that file after. Important info, we are not trying to replace geolocation providers, because they do an important role of validation of the data and of distribution of this data. What we are trying to do is to ease and automate the communication with them, so reducing this email exchange. And also another thing that we are proposing in the draft is a safe, easy way to consume this data, because at the moment there is no approach for it, and there are some original and quite unsafe way also that they are used. So basically, by linking from the INetNAM, we already given some assurance of the ownership of the resource, because basically when you fetch prefixes in the file, you have to just read the one they are inside the parent INetNAM that you use to reach the file. Also, there is, in case of weakly authenticated RPSL, there is an optional authentication that is possible, which is a digest of the file signed with the key of the PKI certificate of the prefixes, relevant prefix. So now there is this work item in the RIPE database, and this is amazing. Basically, RIPE will be is the first of the 5 RIRs that started with this, which is to add an attribute, a specific geofeed attribute, so that we don't have to exploit remarks for it. And this will allow to have basically a cleaner solution for sure. And of course, once this is introduced, you may have at most one between the geofeed and remark, and at some point move completely to using the geofeed attribute. So now we are describing also how to consume this geofeed. There is this application again, but it doesn't matter which application you use. The idea behind is the important key. We suggest to use WHOIS dump. All RIRs produce those. Also, in general, geolocation providers and other parties are already familiar with these dumps, so it's nothing new. You can parse them all at once and basically collect all the geofeed URL, fetch this, and create essentially a big geofeed file for all the basically the geofeed that you found. So this is something that is not, we did it on purpose, because as I said, a geofeed format is already supported by basically all geolocation providers. So if the only thing to do is to create a cron job and run this, create this global CSV file and import that file like if it was a whatever else format. And already some geolocation providers implemented this automatically. So there is this periodic auto fetching, which is great. It's already working out for us pretty good. More are experimenting with it. They didn't release that they have it in place already. But basically, since they support the geofeed file, in case you have any, if you would like, you can, for example, ask them to automate this process and import automatically this file. So my presentation is over. I'm here if you have questions, and of course, I leave here also my email.
There are some questions on the Q&A. Harry Cross, has there been the thought of hosting the content of the geofeed inside the database instead of introducing another external link that could go wrong, please?
I don't think it's really a good idea at all. First of all, having an external link is actually important for various levels. One is because the geofeed information, it's not something that RIPE has to manage or anything. So I will have this URL. It's my duty to keep it up to date. I cannot blame anybody else. We are talking just about a file. Loading this directly in the database can be quite cumbersome for the database. Additionally, you have to keep in mind that having an external file, it is important because in my case, for example, who has access to the RIR database is not maybe the person that is operational, that has to change geolocation of the addresses. So every time you have to ask somebody that has access to do it. Instead, it's much easier to just link to an external resource, and from that moment on, work on that resource and keep care of that resource. If it doesn't work because the URL is broken, that's your fault. That's basically.
Okay, from Christian Bretterhofer, geofeed companies, those companies take XXX euros per month and we give them that data for free. Do we get it back?
So the thing is, when you, it's not that they take data for free. I mean, you have like if your geolocation is wrong, you also lose money because your customers are going to be unhappy. So it's already, the entire pipeline is already in place. So geolocation providers accept corrections by email already, and this is happening for free, for what I know. So it's your interest for them to provide correct geolocation. They will do money anyway if it's your interest to provide correct geolocation, because the only one that can lose money is you if your geolocation is wrong. So basically, we are just trying to make this automatic.
Again, from Harry Cross, second part of my question, this would also bring the benefit of adding the geolocation into Whois.
I didn't get this question.
I think it's just a further reference to not having the external link, but putting it in the database instead. But I think you've already answered that.
Okay. Perfect.
So, that's it for questions.
Thank you very much. Thank you for your time.
Thank you, Massimo. Up next, we have Sander Buskins from RIPE-NCC talking about the cloud migration. Sander, you're up.
Yeah, thank you. I'm assuming everyone can hear me fine. So my name is Sander Buskins. I'm a developer on the RIPE-NCC database team, have been working a lot on the Whois cloud migration, and will be giving the update for this subject. So the cloud work that we have done since the last RIPE meeting. The last RIPE meeting, if you remember, prior to the last RIPE meeting, we deployed the release candidate environment, the proof of concept version of Whois, running in the cloud, running on Amazon, for the release candidate environment, for the community to try out, and for us to also experience running it in the cloud. So since then, we've had a number of Whois releases with preparatory changes. One of the things is Whois, when we run it on premise, we do not run it in a container, but when we run it in the cloud, we will be running it as a containerized application. So we had that at RIPE 81, already running as a container, but now we've extended this further to also abstract us a little bit from the cloud provider. We can also run that elsewhere. Other than that, we've been adding some AWS support. Most notably, this is for the configuration of the application. So when we run Wiz on-premise, we have configurations that we pick up from the file system when the application starts up. In the cloud environment is slightly different. So we actually pull the configuration from AWS. So we've added some support for this to the application. I think it's important to note that the Wiz application itself, like the binary of the application, is the same. We deploy the same version, exact same version to the on-premise as we do to Wiz, to the cloud environment. So it's the same environment or same application. Other thing is UTC changes. Ed already mentioned this in his presentation. So running on-premise is in the Amsterdam time zone. However, running in the cloud environment in the UTC time zone. Now, of course, we want to align this to make sure that we're running in the same time zone, because otherwise we might get some very interesting behavior. So for that, we've been going through the application, looking at all the different areas in which we display time zones, we display timestamps, and in which we store timestamps to make sure that everything is UTC. We identified a number of places in the application where we display a timestamp, but not with any time zone information. Sometimes this is in UTC, sometimes this was also in Amsterdam time. And then we've now aligned this everywhere, so it's now all UTC. That is the release that will be deployed, the 1.1.1 release. Other than that, we've been looking at the cloud architecture, or a number of things that we have to improve upon. One of those is the HTTP rewrite rules. So the on-premise environment that we have with like Apache servers in front of the application that deal with a bunch of HTTP rewrites. Now in the cloud environment, there were ways to replicate this. Not the load balancer himself did not support what we needed. So we actually spoke to the AWS solution architects, came up with like a number of different solutions, possible solutions. However, we want to keep it as straightforward as possible. So in the end, we decided to actually put the rewrite in the application itself, in the Wiz application. There's a couple of advantages to this. It keeps the architecture simpler. We can reuse this also on-premise. We can, in due time, get rid of the Apache servers, also simplify things on-premise. And also it allows for testing these rewrite rules, something that we don't have at the moment, but for Wiz we have quite an extensive test suite that we run every time we build the application. So we can now also test these rewrite rules. Other thing that we were looking at is the database availability setup. So on-premise we have like one primary write node with a standby write node, and then we have the Wiz application itself runs on 4 different physical machines, and on this machine is also a database, a read instance of the database, which is replicated from the primary database. We cannot really reproduce this in the cloud environment as such, because the application will be running as a container. So we were looking at using like a primary instance and then a standby instance, and no read instances. But of course, because it's not on the same machine, this has like a performance penalty. So we've been doing quite some load testing, looking at this situation. What is the impact of that? And also if we have separate read instances for the database per availability zone. When we run the application in Amazon, we're running it in 3 availability zones. Yeah, we don't want, if we run the read replicas there, yeah, again, we need to look at the performance. Other things that we were doing, so when we deployed the proof of concept back at RIPE81, it wasn't feature complete in that IPv4 was working, IPv6 was not working back then. We have since had the advantage of a landing zone that's been implemented for us, which is fully IPv6 enabled, which also allowed us to enable the load balancers in the cloud IPv6, which means that the proof of concept can now be contacted via IPv6 as well. Mail updates, we've added support for that. So that's now also working. The client IP handling, I think we mentioned this RIPE81 as well. For Wiz, it's very important that we know who queries the right database. If you query personal objects, we do some accounting on that. You're only allowed to query a certain number of personal objects per certain time frame. We do that based upon the client IP. So for the REST and sync updates endpoints, we use exported foreheaders from the load balancers. So that was already working. However, for the Huish port itself, port 43, and also for NRTM 4444, this was not working yet. So we had to come up with a solution for that as well within the cloud environment. That runs behind a network load balancer, which does not support exported 4. So we came up with the proxy protocol, which is supported by Amazon. So we added support for that to the application, which means that the client IP handling is now also working correctly for the Huish ports in the cloud environment. And finally, the rewrite rules. But yeah, I think we said enough about that already. So other thing that we did in conjunction with the CCOE, the Cloud Circle of Excellence, which is a circle that was started at RIPE, which has a number of different colleagues all working together on crowd-related efforts. One of the things I did was setting up a landing zone environment. So a landing zone environment is a bit like a data center that has all the networking in place. It's like security controls in place. All of these things are very convenient for us. When we initially started the proof of concept, we didn't really have that. So we just had like an Amazon environment in which we installed the application. So now we have this official landing zone environment. So we have to migrate the proof of concept environment into this landing zone environment. We did that, so it's now fully running in that environment. Apart from that, we are also using some extra environments. So we have the release candidate environment, but of course we also have like a development environment, and we are slowly but surely moving, setting up extra environments to move things across. Other things we've been doing is a lot of functional integration and load testing. So for load testing, I already said that it's the database connectivity, which is our main focus point there. We want to make sure that the performance is similar to what we experience on-premise. Integration testing with other systems, and a lot of functional testing. The functionality of the application itself in principle doesn't change, but wherever we do touch the infrastructure, we want to make sure that the functionality is still working correctly. Also, we've had a cloud partner that's been helping us reviewing the architecture that we came up with and helping with improving the setup in general, looking at things like monitoring, alerting, also looking at all the parts of the architecture, in which ways they can fail to make sure that we achieve like a maximum availability. And also the Terraform scripting that we use to provision the cloud infrastructure. We've also been helping with reviewing that and improving that. And another thing that we've been doing is we also have some scripting. For example, for split files, when we export these on a nightly basis, these need to be moved onto the FTP server. So we have some of those supporting shell scripting going on. We need to include the cloud environment in that as well. So working on that as well. So next steps for us is finalizing the database setup. As I mentioned, there's a couple of ways that we can go. So we need to finalize that and make decide which one we're going to go with. Deploying the final preparatory Huish release 1.101 with mainly the UTC changes. Other thing that we'll be doing is we have an internal test environment, a bit like an acceptance environment that is also being used in Huish environment by a lot of internal systems in RIPE. We are going to move that one to the cloud, and then we can do some extensive integration testing with all of these dependent systems. So any issues that we then bump into, we can tackle those. Other thing is the external security pen test. So we're going to have, once we deploy to the cloud, we need to have this security pen tested to make sure that it's all good. And finally, for switchover and failover testing, we need to conduct that extensively as well. I'll say a little bit more about that in one of the other slides. We've had quite some community feedback on the cloud and the Huish cloud proof of concept, for which we thank you, and looking forward to further community feedback. We'll definitely look at. Other thing that we have is the internal review. So we've been looking at the whole Huish cloud migration with legal, like from a cost point of view, information security. So that's also ongoing. what we've been doing is for all the environments that we've been building up, we've been meticulously writing down all of the steps that are involved, which result in a detailed go-live plan. We plan to rehearse this a number of times so that when finally we go live, things go according to this plan. And we'll publish like a somewhat more high-level plan to the database working group. And then finally, we're aiming for a Q3 go-live of Whois. And after that, we'll be looking at scaling down some of the internal environments because we don't need like 3 or 4 development environment, test environments, etc., etc. So for the service changes, what changes when we deploy this to the cloud? A number of things. We'll be relying a little bit more heavily on DNS entries. So we'll be setting a lower time to live. And it's very important that clients do not cache indefinitely these entries. Because we're running in free availability zones. It could be that one of these availability zones is not available for whatever reason. So that means that then the client needs to fall over to the next availability zone. Also, the load balancers and Amazon support HTTP2, so that will be supported. The SSL certificates will be signed by the Amazon root CA. This is already the case for the RC environment. As Ed mentioned in his presentation, we'll be dropping support for some weaker servers, which are not supported out of the box by the Amazon load balancers. Other thing which changes is for whois.ripe.net. At the moment, you can connect to that for REST and sync updates as well on port 80 and 443, so HTTP, HTTPS. However, when we move to Amazon, that will no longer be the case. So you can only connect to that port 43, the Whois port, and 4444 for NRTM. And finally, we'll be publishing a Labs article with explaining these service changes in detail. So for UTC, it's a bit of an overview. It's mainly in response and notification header and mail message sync update and Whois REST API. They're now all being displayed in UTC, and we're also displaying the time zone information. And the same goes for the list versions and the show versions. So for switchover, which was also published in the Labs article, we'll be running Whois on-premise and, of course, in the cloud environment. The cloud environment, AWS, will be our preferred live environment. But what we want to do is we want to switch over regularly, which is on a DNS level. So normally the DNS will be pointing towards the cloud. However, when we perform a switch, we will switch the DNS entries to point to the on-premise environment. We want to do this regularly. Aim to then switch over within 30 minutes. The aim of the switchover is to make sure that if ever we need it, we know for sure that the switchover will work correctly and the on-premise environment will work correctly as well. So if ever we need it for failover, in cases like AWS downtime, we can then switch back to on-premise. That should then happen within 1 hour. And in principle, if AWS is not available, the primary database will be in AWS, so we will not be able to handle updates. So it will be read-only for queries. And if it turns out that there's any extended downtime in AWS, then we plan to move the primary database back to on-premise. And that concludes my part of the presentation. So I'm handing back over to you, Ed, for questions.
Right, we have 3 questions at the moment. Randy Bush, how AWS dependent has this become? I.e., how much effort to move to Google or European cloud provider?
Mm-hmm. So the answer is not at all. So we're being very careful to maintain our in-house solution as well in parallel with AWS. We're trying to do this one step at a time, and we're taking one cloud provider right now, but we're not ruling out using a different provider in future.
A question from Harry Cross. I noticed from the other AWS RIPE talks and PowerPoint presentations that usage has been made of things inside the Amazon ecosystem like Fargate. Has some justification or studying been done on the rationale of that and evaluating the risk of vendor lock-in?
So the answer is yes, we do take advantage of AWS specific features because it makes our lives easier or it improves availability. So specifically, Fargate does simplify the deployment a lot because we don't have individual servers to worry about anymore. We deploy the application within a container, and the AWS takes care of the orchestration. But at the same time, we can deploy the application jar standalone to our servers on premise. So we will take advantage of AWS specific features where it makes sense, but we're avoiding vendor lock-in. And that will also be very important going into the future as well. So not just for the migration now, but it's something we will be keeping very much in mind in the future.
From Shane Kerr, the goal of the database in the cloud is to get additional geographic locations, I guess not load, since the on-premise will handle the same load.
Yeah, absolutely right. We're not looking for additional server capacity just to handle load, because we know our load is being increasing, but it's quite predictable, and we know we've over provisioned our environment, so we're quite familiar with the load that's needed, and we've done load testing as well with production data, so we're quite confident on the cloud side too. But the idea with additional geographic locations is to improve availability. Currently, we're in one region in 3 availability zones, so we'll be resilient to a failure in 1 or 2 availability zones. That's the idea. But in future, we'd like to expand to multiple regions in case a whole region is taken out, that we can be resilient to that. But we're mindful that the data, there's a lot of personal data in the database, and we need to keep within the EU to simplify GDPR compliance.
From Elvis Villar, I believe it is a very bad idea to have the main database in AWS. Please reconsider. From Rudiger Volk, how far-fetched is the idea of including the alternate targeting to an alternate secondary cloud provider in the test suite process?
If I understand that, I take that to mean that we can test using an alternative cloud provider. Sorry, so I'll try and answer, but we will try, and we will leave the door open to supporting additional cloud providers. And the application is open source. We'll be running it standalone on premise, so it will be a possibility.
Also from Rudiger, any preparation to allow load management?
Yes, well, we're doing load testing to anticipate, to size our environment, to anticipate the production load, and there will be an available. It will be easier to scale up and scale down as appropriate using a cloud environment versus on premise. So
okay,
sure,
so really late. I think that's enough for the questions.
Okay, apologies. I don't have time to answer fully, but I can follow up on the working group mailing list.
Perfect.
Thanks for your time.
All right. So we're running a little short on time. Next up, we have Dennis, who's going to be talking about the NWI proposals. We may run over a minute or two. For those of you that have to leave, thank you for attending, and we'll follow up on the mailing list. We're also still looking for an additional working group chair. If anyone's interested, please reach out to the chairs. And with that, Dennis, I'll let you take it over.
Thank you. I'm afraid no video because I'm using a pretty crappy Chromebook, and if I turn the video on, you'll lose the sound. Okay, let's quickly run through this. NWI 1, stay on top of abuse contact changes. We've never had any support for this work item, so we recommend to cancel NWI 1. Anyone disagrees, please take it up on the mailing list with us. NWI 2, displaying history. This is an action point from RIPE 69. It's been open for almost 7 years. We get one comment every few months, but no discussion, so it's not enough for a consensus. So the chair would like to make two recommendations based on the comments that have been made over the years. One is to drop the arbitrary limit of deletion point of recreated objects. At the moment, you can only look at the history back to the last time it was deleted. The other is to allow the history of deleted objects that haven't been recreated. Because again, all the history is still there, going back 20 years. So it's possible to do that. If you support or object either of these recommendations, please say something. And we need more than one person to comment in the next 3 months, otherwise we can't draw a consensus. Anyway, for multiple status attributes, this was about when you assign a full allocation, the workaround is to create 2 smaller assignment objects, or we could allow 2 status attributes in very defined situations. Now we have these small /24 allocations and people are talking about having to make /25 assignments. Maybe this idea is more useful now, but again, we still have no consensus on it. So if you consider this to be important, support it. Otherwise, we'll recommend to cancel NWI4. Anyway, the SSO authentication groups. Phase 1 is completed. All non-billing users are synced with the auth group. There was a long discussion early 2019 on phase 2, which was having user-defined authentication groups. It had some support. We've had no comments for 2 years. So this is the final call. If this phase is considered useful, let us know. Otherwise, we will cancel phase 2 and mark NWI 8 as finished. NWI 10, definition of country. As Ed said, phase 1 was completed last December. The country attribute has been added to the organisation objects with type LAR. The NCC is currently working on phase 2, adding it to the PI referenced organisation objects. So this is ongoing. NWI 12, NLTMV4. There's been a lot of interest in this. There's a problem statement being proposed. The NCC is to set up a BOF on Zoom about the way forward. There will be a doodle poll to pick a date and time. Please check the database working group mailing list for details on that. NWI 13, the new GeoFeed attribute. There is a consensus to move forward with this. The NCC has done the impact analysis. We are waiting for the legal review. So this is in progress. Other issues that have been discussed recently or in recent months, UTF-8, personal data, authentication of updates, particularly with passwords, white pages. There will be follow-ups to come on the database working group mailing list over the next few weeks or months. All the NWIs, you can get more information from that URL. So, any questions?
There's no questions that seem to be in the online.
Okay, thank you.
With that, we can take this discussion to the mailing list, and we're just about on time. Thanks everyone for attending, and thank you again to the Secretariat and our stenographer and everyone else who's made this session happen. Thank you to all the presenters, and we look forward to seeing you at RIPE 83.
Thank you, everyone.